Okay, so good evening, students. So, students, we are here on Sunday for a very important chapter which we have already completed half of it. Okay, we have already completed half of it, not half of it, actually 40% of it, but still we need to go for the 60%. Then only we will able to solve sample question papers. So, the questions will be only easy if you do the theory part first, right? Okay, modern periodic table. Yes. Okay, students. So I'm sure that most of you have attended my this particular revision part one. Now we are going to the part two. So today I'll be completing this part two also, student. Okay. But before that, let me give a quick recap. Stop recording. Why? Start recording. Stop sharing. Yeah. Okay, let me give me the quick recap. So what all we learned in revision part one, student? Part one we have learned the physical properties. What are metals? What are non-metals? This is what we learned in the first part non-metals. So you know what are metals. So left side of the dotted line are metals, right side of the dotted lines are non-metal. That is what we read in the revision part one. Then we have learned physical properties. How do metals look like? Are they solid? Are they liquid? Okay. And again, we have also seen the physical properties of non-metals. So how do non-metals look like? You see, most of them are gases, fluorine gas, helium gas, krypton gas, but some of them are liquid. Can anybody say what is that liquid part? Bromine is liquid. Okay, like that we have seen all of them, student. Okay, what are the physical properties? Okay, like you see here, they most of them are solids, but you see mercury is liquid at room temperature. Like that we have seen some of them. Then we went to the physical properties only. I have explained the physical properties, like are they good conductors of electricity? Like most of the metals are good conductors of electricity, good conductors of heat. They have high melting point because they're solid. They have high boiling point because they are solids. Like that, we have seen properties. And then we went to the properties of the non-metals. Here we have seen they are already gases. They have weak, they have low melting and boiling points, most of them. But still there are some exceptions. Carbon, diamond, and graphite are the pure exceptions where we have seen what is the exception. So they are already deprived of electrons. They can't conduct electricity. Okay, but graphite being another form of carbon, it's a very good conductor. It's an exception. Okay, they are poor conductor of heat. They have low melting point. But diamond being a carbon form, it's a very good conductor of heat. Okay, these all we have seen. Okay, then we have finally entered into the chemical properties, student. Chemical properties of metals we have seen. So we have seen two things in the chemical properties. What did we see? We have seen metals with oxygen. What happens? And what if they reacted again with water, what will happen? This is what we have seen. Let me give you a quick recap. Okay, so we went as per the group wise. Group number one, group number two, group number three, we went like this, student. Okay, so how do we know they still, sir, in non, sir, if they are exception, how do we know they still are in non-metal? So that's the reason I said, right? We have so you see, if at all I am saying this is one group, they are 95% same in the characteristics, but 5% they will be differing. Today you will be seeing, you see, this is a group, they should have same chemical properties, but this fellow will differ today. Okay, so that's things you need to remember, students. Okay, exception, that doesn't mean you don't have logic. You have a logic why it is different, but your CBSE grade 10 logic is not enough to understand it. Okay, you need to go for class 11, 12 to understand why this fellow is behaving differently other than all of them. Okay, okay, students. So we just started with metals reacting with oxygen. Metals reacting with oxygen we have started. What did we learn? Metal plus oxygen gives. Can anybody say what will metal plus oxygen gives? Like Na is a metal plus O2. Can anybody? Yes, very good, very good. Ponnappa, Aparna, right answer. Very good. Strugal, right answer. Okay, Jahanavi, good. Narendra, good. Okay, metal oxide. Very good, Tanish. Metal oxide. Okay, so metal oxide is right answer. Okay, so Na2O. Why water will come, beta? Why water here? Okay, Valency, Fadila, metal oxide, Rujuta, right oxide. Maya, right answer. Okay, student, this is the first thing. So we have seen this first group. will behave very rigorously with water. They all will be mixing properly with the water, student. Yes, yes, combination reaction. You can take it as an example. Okay. Similarly, similarly after reacting with oxygen, we got metal oxide. Metal oxide. Now the question is, will metal oxide mix with water? That is what we have seen in the last session. Mix with water. Whatever metal oxide has formed, will it mix with water? We have seen first group, it is not only reacting very easily with oxygen and giving oxide, it is also reacting with water heavily. Quickly it is reacting. That is the reason this group is called alkalis. They are reacting, their oxides are reacting with water vigorously. Okay, their oxides are reacting with water vigorously. So we have seen that if they both combine, you will get NaOH, sodium hydroxide, NaOH. Yeah. So first group, we have understood that it reacts with oxygen vigorously and their oxides will mix with water. This is called alkali group. Okay. Next, we went to the second group. In the second group, I took one example, Mg, metal plus oxygen. Obviously, here also magnesium oxide. Okay. Mg, yeah, MgO, magnesium. So this also reacts with oxygen heavily, metal plus oxygen heavily, but not so heavily as the first group. First group was very rigorously. This is okay. They are good reacting with oxygen. Okay. Now what about the water? So are they reacting with water? Their metal oxides are reacting with water. The answer is they are reacting with water, but I think they're partially reacting. Yes, they're partially reacting. So we came to the conclusion second group also reacts with oxygen, but not so fast as the first group, and their oxides are partially dissolving with water. So we are calling it as alkaline earth metals. Alkaline because they are partially reacting with water. Earth metals because they are found in the earth's crust. Like Ca, it is found as calcium oxide in the earth's crust or calcium carbonate in the earth's crust. Today we'll be seeing it. Okay. So that's the reason. So yeah, so that was on second group. Next we went to the third group. Aluminium will not react with oxygen with full oxygen. We need to heat it, heat the oxygen. So aluminium will react with oxygen, but on heating, on strong heat, on heating it will react. Again it will form Al2O3. Metal oxide it will form. But will metal oxide react with water? Is the third group oxides reacting with water? The answer is no. Aluminum oxide was not reacting with water. Aluminum oxide was reacting with acid and base. So we said this particular aluminum oxide is amorphous. The one who reacts with both acids and bases is called not amorphous. What is that, student? Not amorphous.
Sir,
I'm sorry.
amphetamine.
Amphoteric in nature, exactly. Okay, so this is amphoteric in nature. Okay, so these are alkalis, these are alkalines, these are amphoteric in nature. Okay, then we will not be seeing all the transition elements. We'll be looking only important things like zinc. Zinc also reacts with oxygen, but again strong heating, and its oxides are again not dissolving with water. Its oxides ZnO will only react with acids and bases, so it is also known as amphoteric in nature. It is also known as amphoteric in nature. Okay. So in that way, we have completed with oxygen and the oxides with water. I am not reacting metal with water directly. Metal with oxygen I have done, then I have reacted with water. That is what we have seen in the previous session, student. That was a quick recap which we had done, I think, 2 weeks before, I guess. Okay. Like you see, copper also reacts with oxygen, but not so easily on strong heating. Iron also reacts with water, but not so easily on strong heating. Okay. And the one who will not react with oxygen even on strong heating, silver, gold. Okay. So like that, we have understood some of the important metals from this blue color group: silver, gold, and silver, mercury, Ag. Okay. Like that, we have understood, student. Okay. So that is what we have done, I guess. Okay. We stopped it here, I guess, student. Okay. Okay. Okay, okay. Let us start with the next part. Okay, very good to see Narendran metal hydroxide. Yes, right. Okay, so let's start with the next part. Now, what will I do, student? Let me erase all these things. Let me erase all these things. Now, what will I do? I'll directly react metal with water. Here, I have reacted metal with oxygen. Whatever the compound formed, then I have reacted with water in the last week. But now what are we doing? Directly metal with water I am doing. Okay. So metal plus H2O, water. What will happen? We'll see. Okay. That is what today's starting point. Reaction of metals with water. Okay. So I'll be a little bit fast also, student. So stop me wherever you're finding it difficult. Okay. And the students who already learned from me, I think if it's just to make you memorize the things rather than making you understand. Metal oxide plus hydrogen gas. Oh, how can that be? Okay. Acha, so okay, you are giving the reactors. Yeah, right answer. Okay. So students, you need to remember this is what the basic. Metal plus water is metal hydroxide plus hydrogen. Okay. But metal plus steam is also H2O only. But it is water is liquid, steam is gaseous. That's all. This is the chain. Okay. So metal may react with water. Metal may react with steam. If reacts with water, it's metal hydroxide plus hydrogen gas. Okay. Metal plus steam, metal oxide plus hydrogen gas. Okay. This is a basic thing which you need to remember. Yes, iron reacts with steam, student. Yes. Metal hydroxide plus hydrogen gas. Okay. Okay. Okay, so let us start with the same first. So let me start with the first group, student. First group. So here you see famously what all I'll take. I'll take sodium and potassium as an example, student. Okay, these are the famous examples from this particular group. Okay, okay. So you can see, student, potassium plus water very rigorously. Can you see? It's almost highly exothermic. It will blast. I think I have shown you the video also in the regular session. Okay, you just drop some potassium or sodium in water, it will just rotate and it will get blast. Okay, so here you can just say why it is getting blast, because it is producing hydrogen gas. That's the reason it is getting blasted. Okay, so anyhow, metal plus water, so whatever water I am taking, still cold water. Whenever cold water is not able to react, then I'll use heat steam. Okay, so in the first group we have seen that they are all mixing with the cold water only and reacting so heavily. So metal plus water, metal hydroxide, that is what I have shown. Metal plus water, metal hydroxide plus hydrogen gas plus heat. Okay. Iron rust even if you dip it in water, though it does not react with water. Okay, so iron will only rust if it gets H2O and O2. Okay, it should have both of this combination. In water also, we have that combination. Okay, so student here, why does you see right now we are doing instantly. Okay, if at all I am just keeping water in iron in the water, I want to see immediate result. But if you see the result after 3 months, 6 months, the situation may change. Okay, we are only looking for the immediate reactions. Okay, immediate answer, but it rusts in water. Yes, I said right. That rusts in water because some oxygen is also there, moisture content and oxygen is also there. Okay, so yeah, so again sodium of the first group, so sodium plus water, sodium hydroxide plus hydrogen plus heat. Okay, that is the first thing. So that's the reason, student, these first group elements, they are very difficult to store in the real world. Why? Because everywhere, if you keep it in open environment, in the atmosphere there is a moisture, there is oxygen, and they rigorously react with water and oxygen. That's the reason they are always stored in kerosene. Alkali metals like the first group 1 metals, they always dissolve, they dissolve in water fastly. That's the reason they are called alkali. But if I want to store, I'll store it in kerosene where they will not be getting that. Okay, prevent the water and oxygen. Yeah, so kerosene is a you see, student, H2O, water and kerosene are totally different. Kerosene is a polar, here the polar bonds will be there. Sorry, covalent bonds will be there. Kerosene, it's something like C and H bonds come there. Okay, so all your doubts are from higher level. Why, sir? Why C and H? You see, C and H bonding, H and O bonding, the energy requirements are different. In the kerosene, if you keep Na, it can't break the C and H bonds. Okay, but in water, it can break H and O bonds and give H2 outside. Okay, alkalis are basics. Exactly, you're right. Okay, you see Na plus H2O, it is giving NaOH. Base, sodium hydroxide is a base. Okay, okay. Okay, so that's what they are stored in kerosene. Okay, now let us go to the second group. Let us go to the second group. Is water a salt? Water is, I don't know what is water is salt. So please ask the question rightly. Okay, second group. Let us go to the second group now. Will also they react with the water? Let us see. So student, in the second group, only calcium will react with the cold water. Okay, so that's what I said, some exceptions, right? You see, only in the second group, calcium will react with the cold water and metal plus water, metal hydroxide. The formula still remains same. Huh? Metal plus water, metal hydroxide, the formula will remain same. Okay, plus hydrogen gas. Okay, now, sir, why this is cold water? So that means in that group, everybody will be with the cold water? No, the answer is not. From calcium to remaining, they all are with the cold water, but above one like magnesium and beryllium, magnesium especially, it is with the hot water. It can't react with the cold water. Okay, so that is what you need. So magnesium plus H2O, you see, I'm using little bit of heat, okay, to react magnesium with water. Again, metal water, magnesium hydroxide plus hydrogen gas. Okay, can anybody say why is that? Like SSC Telangana students, at least you should know. You have some extra topics than these students. What is the reason? So you see, this all should react with cold water. When I have done the experiment on calcium, it is reacting with cold water. They all should react with cold water. But why? Why these two? I think beryllium not at all reacts actually. So anyhow, we are focusing in CBSE on these two elements only. So magnesium will not react with cold water. It reacts with hot water due to presence of ions. What is ions? No, no. Okay, so student, there is a concept known as ionization potential. Ionization potential. Okay, I'll give you in a easy meaning. No, student, you should not compare with reactivity. I am framing reactivity series now. Don't give the examples of stuff from reactivity series. This is more reactive. No, we are deriving the reactivity series from this all experiments. Okay. Yeah. So students, so if at all the such question comes, you can give it in a simple way. Magnesium atomic number is 12. So if I draw magnesium and calcium, which is magnesium, which is calcium? Obviously, magnesium, sir, atomic number 12, it will be smaller. Calcium, the atomic number is 20, it will be bigger. So you know electrons are revolving around it. So you see here positive charge and electrons, protons and electrons, they are strongly bounded. But here, as it is bigger in size, the protons in the center and electrons are on the borders or on the shells. So the distance is more. Yes, Rujita. So which metal can easily lose its electrons? It is small, so bonding is more. It is big, the bonding is less.
Sir, calcium can
Yes,
easily.
that's the reason, student. Calcium, even with cold water, it is able to react. It can able to lose electrons. It is able to react. But magnesium, being very small, its particular electrons and protons are tightly attached, so it is not able to lose or form in the reaction with cold water. That is the reason we are increasing the temperature by giving hot water. Okay, so there is a concept of ionization potential. Yes, Maya, you're right. Okay. Okay, so this is so that's the reason. The exception doesn't mean we don't have logic. Exception means we have logic, but our knowledge at this level we can't understand that logic. Okay, so again, so this will react with cold water. This will react with water. This with hot water, and the remaining all are with cold water. Jahnavi, did you understand those that example, calcium and magnesium example?
Yes.
Okay, yeah. So now let us go to the third group, student. Okay, so student, if magnesium is reacting with what? Hot water, obviously the magnesium will react with steam. Steam is much more hot water. Okay, it's a gaseous form. Okay, obviously now, but formula will change. Metal plus steam, metal oxide. Why? The basic formula we have already written. Metal plus steam is metal oxide. That's the reason. Now magnesium with steam will give you magnesium oxide, metal oxide, and plus hydrogen gas. Okay, so that is what you need to know. Okay, so you should not remember everything. You should remember only these two statements: metal plus water, cold water, hot water, metal hydroxide; metal plus steam in the gaseous form of water, it is metal oxide. Only these two you should remember, and the path you should remember which group is which way it is behaving. Okay, let us go to the third group. So, okay, so obviously first group, second group finished. This is the third group. Okay, so I'm not speaking about the transition metals. So these are somewhat very complex to remember. Still, we will learn some of the important metals which we deal with. Iron, zinc, copper. We'll deal with that. Okay. Now let us go to the third group. Third group will only react with the steam. Aluminium only react with steam, not with hot, not with cold water, but only with steam. Metal plus steam, metal oxide, hydrogen gas. Okay. And similarly, after the third group, as I said, some of the important metals we should go: zinc, copper, iron. Let us see them. Okay, let us see them. What are those? Zinc also reacts with water, but only in the steam form. Zinc oxide, metal plus steam, metal oxide. Iron, metal plus steam, metal oxide. Like that. Okay. Yes, that's all, student. Okay. So in that way, we have come to the conclusion, sir. First group vigorously reacts with cold water. Second group, from calcium, it reacts with cold water. Above calcium with hot water. Third group, only steam. Zinc, copper, iron. So one second, let me see what all items. Zinc and iron, not copper. Zinc and iron, they will only react with steam. Okay, zinc and iron, right? Yeah, zinc and iron. Okay. Now, sir, what about the copper? What about the silver? What about the gold? Silver and gold. These are also important, right? So, how are they? Are they mixing with hot water or steam at least? The answer is nothing, student. Okay. Metals not at all reacting with steam. Copper doesn't react with steam. Lead doesn't react with steam. Okay. Silver doesn't react with steam. Gold doesn't react. How to remember this, sir? Student, gold and silver are easy to remember. They are noble, or we can say noble elements or noble metals. They are very rarely mixing with the thing. But you see copper. Have you seen your geyser? When you see your geyser, in your geyser, the geyser tank is made up of copper. Why, sir? Why like that? You see, geyser always hot water is there, and mostly some of the steam particles are also there. So if at all you make with another, the tank inside the geyser, if you make with another metal, it will react. Okay, but you don't want it to react. So that's the reason in the geyser, the tank is made up of copper. Or else you should look whenever you're buying the geyser, is it the copper tank or not? Okay, to make the cost reduction, to cut the cost, they are sometimes making with aluminium, but after some years, the aluminium will totally react. You will see some holes in the geyser tank. Okay. Yeah, so these four are exceptions. So as I said, most of your questions are on exceptions. Okay, I'll give you. So how many MCQs he is framing, which part he is framing, I'll give you today. Okay, most of the questions are for exceptions. Okay, students, in that way, we have completed the metals with oxygen, metals with water. Sir, at the end, after this topic, you will compare this. Yes, yes, exactly. Yeah. Why is not make a geyser with lead? Student, girl. I should also see the cost, right? So you see, lead, we use it in the ammunition. Okay, it is lightweight and it is costly. But copper, if I use lead in spite of this copper, it definitely your geyser will be lighter, but your cost will be very high, student. Okay. Yeah, that way we have finished this. Okay, so students, so we have finished metals with oxygen, metals with water, and metal oxides with water. These three we have finished. These three we have finished. So students, please pause me if at all you're okay. Yes, that is also one of the reason, but you can just shield it, right? You can shield it with something. If it is poisonous, you can shield it with something, but you are not at all using lead. Okay. Reaction of metals with acid. Yeah. Now let us go to the acid, student. Now let us go to the acids. Okay. Yeah. So there is some activity. I think you can see it. Okay. So this activity is also important, I guess. It's very easy, student. So now metal with acid you want, right? You will take some metal. You see what did he take? He took some zinc granules. And you need to take acid. What did he take? He took sulfuric acid. He just made that, fitted the core, and from the core, some tubes are taken. So if they are reacting, which gas you are getting? Hydrogen gas. From this particular tube, the hydrogen gas will come. If you are dipping it in soap solution, automatically the bubbles will be forming. And if you use your candle, that will make pop sound. By this, you can say that it is a hydrogen gas. Okay, it is a hydrogen gas. Yes, absolutely. Okay. So metals will react with acid. So in this experiment, we got to know metals will react with acid and always we get some salt and hydrogen gas. Okay. This is a basic. You should only remember this. You should not remember the examples. You should only remember the skeleton part. This is a skeleton. From here, whatever metal he want to give, he may give. Whatever acid he want to give, he may give. But your answer should be, okay, sir, hydrogen gas will come. After that, some salt will come. Okay. Can anybody say why salt is coming here? Yes, Harshini. Why are you seeing salt over here?
The metal mostly are basic, so basic
Very
plus
good.
acid.
Very good. Excellent. Okay, so student, base plus acid, we have seen it's a neutralization reaction. We always get salt. What is base? Base is nothing but metal oxide. Okay, that's the reason, student. Even though we are learning with different topic, again we are learning acid plus base, salt plus hydrogen. Okay, it's the same thing we are learning. Bases are metal oxide. Very good, Sugar. Narendran right. Rujuta right. Okay, so like that. Now let us go by group. Okay, now let us go with the first group. Is the first group will react with acids? And the answer is yes. They react very fastly with the acid. Like sodium, potassium, they react very strongly with the acid. And we are taking aqueous. What is aqueous means? I am adding some water. What does that mean? We are taking dilute hydrochloric acid. Okay. So first group is highly reacting with acid. Obviously, you should get some hydrogen gas. If H is lost, what is there? NaCl, which is nothing but salt. In that way, you should remember. Okay. Base plus acid, sorry, not base. So metals plus acid, we'll always get hydrogen gas. And if H is lost, what is there? Magnesium chlorine, magnesium chloride salt you will get. Okay, so the first group is very fast, highly reactive. Second group is also reacting like magnesium I'm taking from the second group. It is also reacting, but it is somewhat fast, not very fast as the first group. Okay, now let us go to the third group, which is nothing but here aluminium. Aluminium is the third group. So, student, here it will also react with the particular acid because we have seen aluminium is amphoteric in nature. Obviously, it will react with acid. We have already seen it, and that's the reason, but the speed is somewhat still less, moderate speed. Obviously metal plus acid, hydrogen gas, and if H is lost, aluminum chloride is there. Okay, now let us go to the other elements, other metals which are important like zinc, copper, iron, gold, silver. Let us go to them which are important. Zinc will also react with hydrochloric acid, and but they are still less than other. You see, as I am switching from group 1, group 2, group 3 to some of the important metals, the speed is reducing. First group very fast, second group little fast, third group moderate, and the remaining elements are somewhat less speed. Okay, student? Yeah, so in that way, we can just say that particularly, yeah. So now, can you say, but which metals will not react with acid? Copper chloride will also get, right? So, okay, will copper react with acid? Can anybody? Will copper react with acid?
Yes, sir.
Yes. Narendra? Yes or no?
Yes.
Tanish is saying no. Harshini is saying yes. Okay, so Harshini, copper you are saying that it will react with acid, right? You see,
Yes,
student,
sir.
reactivity series, do you remember? In that copper and hydrogen both are there. Which is more reactive? Very good. Aparna, Rujuta, Tanushri. Yes, Harshini?
Yes, sir. 1 minute.
Okay, hydrogen is more reactive.
Sir, hydrogen, I think.
Okay, so that's the reason, student. It is very less likely, less chance that they both react. Okay,
Sir, but copper chloride is there, right?
copper chloride is there, but copper chloride will come from HCl only. Did I say that? It may be with other combination. I'll check it. Okay, I'll check it. But mostly there is no less chance. Okay, because
Yes,
it
sir.
is higher react. Okay, so students in
Sir,
that,
but
yeah,
then copper does react with acids, right?
so you need to say something like H2SO4, so you are able to see CuSO4 also. Okay, I'll come to
Yes,
that
sir.
point when I deal with hydrogen. I'll come to that point. That's a neutralization reaction that should not it produce. Yeah, so student, it's not exactly neutralization reaction. You're absolutely right, Janavi. But neutralization reaction is completely acid plus base, but it's only the part of the base. What is base, beta? Base is metal oxide. But am I reacting with metal oxide with acid? It's only metal. Okay, that's the reason you are not getting water. But if you go for neutralization reaction, definitely you will get H2O also. Okay, it's only a part of base, not the total perfect base. Yes. Okay, so yeah, so student, if that all the question comes, so in the first group, who is more reactive, Na or K? Experimentally, this seen K is more reactive. I think that is the reason I have made a statement. In group one, among Na and K, who are reactive? K is more reactive. Yes, Harshini, right answer. Yes, I'll just see, student. I think there is some exception. That's the reason I said I'll discuss it when I deal with H. Okay. Okay, yeah, you see here, Cu plus H2SO4. What she just asked, copper sulfate. Copper reacts with hot sulfuric acid. That too concentrated only. Okay, that's the reason we said some exception is there. Okay, so as per reactivity series, it should not react. But if I heat it, if I make some concentrated, there is a chance that it will react. Okay, understood, Rujita?
Yes, sir. I was saying that copper oxide and HCl can react, right?
Copper
That double
oxide and it.
displacement.
Yeah, so this is again which type of reaction? This is
Double.
again, I think, double displacement reaction. Yes. So there again, reactivity series I'll not consider. So you can
Okay.
just say copper chloride and H2O will form. Okay, yes, student. So that student, these all are aqueous. These all are dilute. So if at all you are getting CuSO4 means definitely that fellow would have taken concentrated. That's the reason you will get CuSO4, copper sulfate. Okay. Yeah, so now there is exception. Okay, so still now we have learned very fastly reacting with acid, fastly reacting with acid, moderately reacting with acid. Zinc is still slow, and this copper, silver, gold, they don't react with acid. Okay, that is what we have seen right now till here, right? Iron also will react with acid and give hydrogen. Now there is an exception. Which exception? There is some acid which will give some exception. What is that acid? Nitric acid. Okay, nitric acid is an exception. Very good. Okay, so metal reacts with dilute nitric acid. Hydrogen gas is not there. Okay, very important question. Huh? Very important question. Metals reacts with acid. Definitely you will get hydrogen gas, but there is one acid which doesn't give hydrogen gas. It is nothing but nitric acid. Okay, nitric acid. The reason why? Reason is yes, Narendran. That's an exception. Exception, right? But when you pour on acid copper, so that's a concentrated acid, student. Magnesium and magnesium. Yes, right answer. Very good exception. Exception. Ponnappa. Yes, that's right answer. Okay. So you see, student, copper with nitric acid. I'm taking the dilute only. What is happening? So definitely some salt will come. So copper nitrate salt came. But soon hydrogen gas comes out. This fellow nitric acid is a strong oxidizing agent. What does that mean? It will add oxygen to that. So H2 will become H2O. Again, whatever NO3 is there, it will sometime behave NO, it will sometime become NO2, or sometime it will become N2O also. Okay, that's the reason, student. This is an exception. So soon hydrogen comes, it will add some oxygen and it will make it water. Okay. Besides that, there are some other components like nitrogen oxide, nitrogen dioxide, like that. Okay. Nitric oxide, nitrogen dioxide, like that. What are the questions? Arshini, yes. Oxidized. Okay. Okay, so students who have already taken notes, that's fine. Others, you can take fastly the screenshot. Okay. Yes, Maya. Is there any metals who are giving an exception to nitric acid? I am saying all the metals. I am saying metals reacting with nitric acid will not give hydrogen gas. They will give some other thing. Yes, right answer, Harshini. Maya. Yes, Tanish half answer is right. Yes, Strugal half answer is right. Do you remember? Forgot, Maya? Yes, Fadila.
Manganese,
Ah, very good. Right answer. Yes,
sir,
Fadila.
amphoteric oxide,
Huh? No. I'm asking metals. Yes, sir.
metals. Oh,
Metals
uh,
with nitric acid, they will give hydrogen gas. For Punappa, right. Rujita, right. So exception in exception.
sir, magnesium.
Very good. Magnesium and manganese. Right answer, Maya. Okay. So those are exception in exception, student. Okay. So you see, this magnesium with nitric acid, first of all, it should not give hydrogen gas. it should give H2O. But you see, but these two metals, again, they give hydrogen gas. Tanushri, understood beta? Exception mean?
Yeah, sir.
Okay, yeah.
Except
Acha, okay, right. Now not seen you. Okay, magnesium, manganese. Tanushri, right answer. Okay. So these two metals are exception. Again, very, 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 very important. Okay. Yeah, so student, but you see, I did not take dilute. I have taken very, very dilute. What does that mean? I'm adding more amount of water. More amount of water. How much water do you believe? 1 ml of HNO3, 1 liter of H2O. That much dilute I'm doing. Only in that scenario will get hydrogen gas. Okay? So please remember it is very, very dilute. Not dilute. Very, very dilute. Okay, 1 ml, 1 liter. You can assume what is the ratio? 1 is to 1000. Okay. Yeah. So now is there any liquid who can just fuse out these two which are not at all like silver and gold, which are still not at all mixing with anything? Yes. There is some liquid which is nothing but aqua regia. Yeah, magnesium was reacting with water. Yes. Magnesium was reacting with manganese was reacting with water. Yes, you're absolutely right. That's the reason, student, we need to go some more ionization potential, electronegativity, electropositivity. There are many concepts. So, yeah, all I can't explain in this session. Okay, so Ananya Amulya, are you there, student? Ananya Amulya? Ananya Amulya, are you there? Okay, so students, SSC Telangana students, so there are some parts. So I think 15 to 20% syllabus other than CBSE, which I'll be taking after February 16th. So February 16th, you have maths or science exam, student? First exam?
Then math, Feb 70.
Feb 17. And what about science? 24th, right?
yes, sir.
24th. After
25th.
25th, I think, sir, actually.
25th. Okay. So students, after 25th, I'll be covering the concepts which are there exclusively for SSC Telangana. Okay. But I will only accept the students who are on the camera that time. Ananya Amulya, so it's for you especially. Okay. So almost 3 students only. Huh? 3 finals from 17th. Okay. So I'll take only 1 hour session, student. Okay. Okay. So 1 ml is to 1 liter, I said, right? 1 liter, kitna beta? 1000 ml. How is 1 is to 3? Acha, in aqua regia you are saying, okay, okay. Okay, yes, you are right, absolutely right. Okay, it is 1 in aqua regia, it is 1 is to 3. Okay, so what is aqua regia? Nitric acid, hydrogen chloride, or hydrochloric acid. Okay, so it is 1 is to 3. So please remember, you should not say, sir, 3 is there, it might be 3 is to 1 here. No, it's ulta here. Okay, yes, Tanish.
Sir, isn't it 3:1? Three HCl, three parts of HCl, one part of nitric acid. In
No,
textbook, it is mentioned as 3:1.
is it? Harshini, just correct me.
Sir, like there they gave HCl first.
There they gave HCl first, I guess. HCl is to HNO3 will be 3 is to 1. Okay. Yeah, you can see Cl is there, chloro. These two combinations are melting that gold. Gold is aurum, so it is also known as chloroauric acid. Chloroauric acid. Okay. Yeah, this is where the reactivity series has formed. Now you should say, sir, reactivity series has formed after so many experiments. It is not that due to this reactivity, those experiments came true. No, those experiments came true. That is from that we have formed reactivity series. You see, first two groups are reacting with water, reacting with acids, reacting with oxygen, reacting with, so they are highly reactive. The last group, gold and silver, they are not reacting with water, they are not reacting with acid, they are not reacting with oxygen. So you can consider them as very unreactive. Middle, second group, third group, and some of the important metals which we have seen today, zinc, iron, copper, these are mostly not reacting with water. You see, there is no green color. Reacting with acid, but less speed. Reacting with oxygen, but strong heating. In that way, we have finalized this is the reactivity series. Okay, and you said, and you know, how to remember it. Please send cats, monkeys, and zebras in lovely happy cages made of silver, gold, and platinum is what I gave you. Okay. So now if you want to remember in the way you are remembering from the very first session, please continue the same. Okay, students. So I am sure that you all remember this keyword. Okay. So now let us go to the next topic. I am not taking questions, sir. Yeah, only one or two questions I'll take. We don't have so much time. Yes, students, everybody should answer. 13 students should answer me. Harshini, right. Tanish, right. Rujuta, right. Ponnappa, wrong. Maya, wrong. Narendran, right. Jahnavi, right. Aparna, wrong. Fadila, right. Yes, Aparna, okay. So, student, if I'm able to cross 5 meters means I can able to cross 4 meters also. There is nothing to mention. Yes, Maya, right. Shrugal, right. Okay, that means if at all that liquid is melting gold means it can melt every other thing. Okay, right, Tanushri, all of the above. Okay, yes, Narendra, can it melt platinum also? Ananya Amulya, right answer. Aqua Regia, can it melt platinum? So the reactivity series is here.
No, sir.
No, okay, aqua. So you can see gold is platinum is still not below gold. So platinum is not melted by aqua regia. Okay. Okay, in that way, we have finished aqua regia. Okay, reactivity series. I'll not take much. You already remember that. But you see, student, reactivity series, it is arranged in the decreasing chemical reactivity. That's the reason gold is least reactive. It is on the last state. Okay, decreasing chemical reactivity is reactivity series. Okay. Yeah, so you see, student, here in the reactivity series, we have taken hydrogen. Now you should get confused, sir. Hydrogen is a metal or non-metal? So you say, okay, so that's still a great confusion part. Hydrogen sometimes considered metal and non-metal because hydrogen has an ability to lose electrons. Hydrogen has an ability to gain electron. Okay, that's the reason it is metal also, non-metal also in some of the cases. Okay, so here we are taking hydrogen as a reference. Above hydrogen, whoever is there, we are considering they are reactive. Below hydrogen, whatever metals are there, we are considered non-reactive. Okay, that way also, yeah, less reactive than hydrogen, below hydrogen, whatever are there, more reactive than hydrogen, above hydrogen, whatever is there, we are considering in this way. Okay. Okay. Carbon non-metal then. Carbon is a non-metal, student. Why? Carbon is here. You see, hydrogen is here. Carbon is a non-metal. Okay, yeah. So in that way, yeah. So student, with the help of metal reactivity series, you can give many questions of the displacement reaction. You will find at least one question, one MCQ, one 2 mark question of the displacement reaction. With the help of simply that reactivity series, please send cats, monkeys, and zebras. You can directly give the answer. Okay, student? Yeah, carbon can lose or gain electrons. No, who said? Carbon can neither lose electrons nor gain electrons. Carbon can only share electrons. Okay, hydrogen can gain electron, hydrogen can lose electron. That's the reason hydrogen is having a confusion. Always it is mentioned by a dotted line on the metal side. Okay, but carbon it can only share electron, not lose or gain. Displacement reaction. So I'm not taking many examples. Why? Because we have already seen it. Okay. Yeah. So can anybody say what is this? Can this reactivity series helpful to you? Yeah, Narendra.
So then why can't hydrogen be called a metal also?
I am taking it as metals, right? So in the metal reactivity series, I have included metals. Okay. So it's still a discussion part, student. Okay. So many times, sometimes they are considering as a metal also. Okay. So that's a discussion point again. But even hydrogen can create covalent bonds with whom? With whom, student? Hydrogen can create covalent bonds with carbon. So it's not the specialty of hydrogen. H2O, covalent bond. There are some exceptions. Okay. There are some exceptions. Yes, students. Can anybody say how is this possible? Hydrogen, you're absolutely right. Hydrogen. So, student, that is what? Hydrogen can take electron, hydrogen can lose electron, hydrogen can share electron. This is the confusion. But carbon, it is not the scenario. Carbon can only share electron. It can't give, it can't take. That's the reason we have a clear-cut indication carbon should be non-metal. But hydrogen, as these many combinations are possible, we are in the confusion, Sugar. Understood, Sugar? Yes. Okay, reactivity series. Okay. Maya, very good, Maya. Right answer. Yes, Rujita, chlorine. Yes, so Rujita, reactive. So you are saying chlorine is most reactive than that. But do you have reactivity series for non-metals also? Yes, Fadila, right answer. So not possible. Okay. Halogens. Yes, Harshini, right. Okay. Sugar, right. Okay, so student, that's absolutely right. So you see, now you should not compare. You see, calcium, chlorine. So this is metal, this is non-metal. So don't take this. Okay. Now you should take, sir, chlorine is non-metal, iodine is non-metal. So now whether this non-metal will displace this or not, that should be a scenario here. Okay. So here we need to go for the non-metal reactivity series, which I have discussed in chapter number 1. When I come back to chapter number 1, again I'll discuss this point. Okay, halogens reactivity series is what we have discussed, right? Yeah. Okay, so let us move to the further part. Okay, then we are going to the next session. Chlorine is more reactive than iodine. Absolutely right. We have seen the same, Harshini. Okay. Now, students, yeah, please write this, student. You will find one question from these colors, flames, salts. Okay. Either in the case-based questions or MCQ questions, you will find this question. Please write. Okay. Colors of some oxides. Which oxide, which color? You need to write this. I don't know if you have written. That's wonderful in my regular session. Okay. Copper oxide. You see, copper oxide. You just remember the particular. Like during in the electrical connection, if there is short circuit, all the wires will be black. Electrical wires are copper oxide will be forming. So in that way, at least you remember, copper is black, copper oxide is black, but copper, the electrical wire inside the copper is there, that is somewhat reddish brown. Okay, please remember the colors in the case based activities they're asking. So now you got copper oxide. By looking, how can you say it is copper oxide? Because it is black in color. That way you need to respond. Okay. Iron oxide, rust. Iron oxide is again rust, right? Brown. Iron is something is considered as gray. Pure iron, I guess. Harshini, yes.
Sir, in the regular session, you gave it as hot and cold colors.
Yes, that is here.
Sir, which should we consider if they ask a question?
So mostly they're asking on cold only, student. This one only. Okay. You see, zinc, copper oxide, cold black. Okay. Iron oxide is not here. Let me check. Zinc, lead oxide is yellow. Lead oxide yellow. Zinc oxide white. Zinc oxide. Yeah, you can take this one. This one. Metal oxide color.
Okay, sir.
Okay. Jahanavi, are you following, student?
Yes.
Okay. Ayana, how are you, student? Ayana.
I'm fine, sir.
Fine, Ayana. Worried about you. Harshini. Okay,
So
Jahanavi.
can you go to the previous slide? I just wanted to see the color change.
Oh, yeah, same thing. Same thing is written. Only iron, I think you should write here from here. Okay, so try to remember the practical concept. You see, whenever there is short circuit, you see some black thing on the particular copper cables. So that is nothing but copper oxide will be forming black. Iron oxide, you know, rust brown. Iron oxide. Okay. Lead oxide, I think we have done one of the activity in chapter number 1. Yellow precipitate activity. There, from there you can
With
remember.
potassium iodide.
Potassium iodide. Yeah, yes, yes. Double displacement. You're
displacement.
absolutely right. Exactly. From there, you can remember lead oxide is yellow. Zinc oxide, white. Huh? So did we do any activity? I don't think so. Okay, in chapter number 1, we have done many activities today. Chapter number 1, chapter number 2. Chapter number 3, there are less activities and we have skipped some of them. Chapter number 4 is everything something like maths, carbon and its compounds. Aparna, are you following, student? Aparna?
Yes, sir, I am.
So, are you gaining something by ruining your Sunday evening?
I haven't ruined it, sir.
Oh, thank you. Okay. Yeah. So, student, this is what. Okay. There are some other colors. What are the other colors? Colors of flame. Please write it. Huh? Lithium. Color of flame. Red. Sodium. Yellow. I don't know how many you can remember. So, potassium. Lilac. Calcium. Orange red. Copper. Blue green. Tanish.
Sir, which color is lilac?
You see, that's the reason I have added. I know you'll ask this question. Now
Blue.
you recognize what is this color.
Sir, a little darker than lavender.
You see, she said. So girls are very happy with colors. So she said absolutely right. 1 second, student. I should switch on my laptop charging. Okay. So if you remember, these two things are not the one thing which you should remember is the third slide which I am showing now. This one, student. 100% question. This one. Salt colors. Zinc sulfide colorless, iron sulfide light green, copper sulfate blue. These two I'll remember. Why? Because in chapter number 1 we have done some activities. I think zinc sulfate also we have to. Aluminum sulfate, I don't think we have done anything. Please go to the previous page.
So could you send this and the color of salts in the group?
Okay, so will you carry to the exam that particular thing?
No, sir, but it is helpful.
Okay, I'll send it. Okay, right now I'll take screenshot. Otherwise, I'll forget. Acha, I also forgot yesterday's sample paper. Nobody was asking me. So I just want to see who all are serious. Nobody was asking me, sir, what about that sample paper? You said that you will send. Okay, I'll send these three sheets to you. No problem. So magnesium blue, bright white. This we have seen, right? Your first activity in your CBSE. Magnesium, white color light. We trust that you will say no. Dazzling white flame. Yeah, dazzling white flame. Right answer. First activity in your CBSE. Okay, so please remember these colors. Huh? Case-based questions or one of the MCQs will be from these colors. These three sheets. 1, 2, 3. If you don't remember these two, also try to remember this. These at least salts. Okay, so let us move ahead, student. We need to do a lot. Okay, yeah. So you see, student, this is how the questions are framed. He will give this equation. He will ask you the color. So copper sulfate, blue, blue. Zinc, where is zinc? Oh, it's zinc oxide, right? Yeah, it's white color. Okay, so silvery white. This one. Okay, zinc sulfate again colorless, colorless. Copper, red brown. Okay, so somewhat it is becoming black in the experiment, I guess. Little blackish, red brown, reddish brown. Like that, you need to respond with the colors. Huh? Some of the questions are there with this. Okay, why, sir? Why colors are so helpful? Because we have seen in the first chapter, chemical reaction means change in color also happens. So change in color, evolution of some gas, change in the state. Those all we have seen in the first chapter. Huh? So students who are there with me for the first chapter, you should remember those things. Anyhow, if time permits, I'll go to the first chapter also. Okay, so students, next week I'll try. So tomorrow I'll just close this chapter. Tuesday and Wednesday I'll start light electric in physics light chapter. I'll start, student. Okay. So give me 1 week time for that particular slides of that particular biology, your hereditary chapter. Okay, I just started making the slides. Okay, give me 1 more week. Next week I'll try to take a regular session on that particular heredity. FeSO, this reaction has two colors of salts mostly. Okay. Okay, so we'll not just go very deeply with the questions. In that way, we have okay. So electronic configuration. So what is electronic configuration? So it's just nothing but arrangement of electrons in the shells and subshells. You see, this is center one is the proton or the positive charge. Now electrons are revolving around the shell, revolving around in one particular shell. If at all I am arranging in particular shells, the arrangement is known as electronic configuration. Okay, and how did I say how in which way they will arrange? They are arranged in the shell. You see, any atom, the center part is the positive part. Around that center part, all the nuclear start rotating or revolving, student. Okay. Now the first shell is known as K shell. Second shell L M N. K L M N. Okay, K L M N. Now, sir, how many electrons are arranged in one particular shell? You see, this is small. So how many electrons? Two. This is somewhat big. How many electrons? 2, 8. Like that. So what is the formula that you are using it? The formula is 2n square. Okay. So you see K shell, its value is n. 2 into 1, 2. So in the K shell, only 2 electrons can be arranged. Only 2. Okay. In the L shell, n value is 2. So 2 into 4, 8. M shell, third shell, n value is third shell, n value is 3. 2 into 3 square, 18. Like that, the electrons are arranged in this pattern, student. 2, 8, 18, 32. Suppose if I ask you sodium, what is atomic number? 11. That means it has 11 electrons. How are they arranged? Sir, in the first shell, 2 are arranged. Second shell, 8 are arranged. 2 plus 8, 10. But we have 11. So one more electron is arranged in the third shell. So 2, comma 8, comma 1 is the electronic configuration. Okay, that is how you need to say, student. Okay, so noble gases, every noble gas we have outermost is 8 except helium, that is 2 duplet. Okay, why not X or Y? Okay. Okay, so student, so last is 8. So as the outermost valency is 8, so these all are highly stable, or you can say inert. They don't want to react with anything. Yes, Harshini?
Sir, and those gases for the MnO, there 18 electrons are shown, but only 8 can be there, right?
Yeah, you see, there is some particular order. You see, student, what she's asking, sir, here the calcium, you can go for higher gases, something like, yeah, let me take this one, student. Let me take this one. Okay, so she's asking, sir, its atomic number is 36. So how are they arranged? 2, comma, 8. Next, 18. 18, 19, 20, 28. So what is the other thing? Another 8. Yeah, what's the doubt, Harshini? I think it's right?
Yes, sir, but there can't be 18 electrons, right? Only
Ah,
8
yes,
can
yes.
be there.
Yeah, so student, when you are arranging in this pattern, there is one exception. What is that exception? This is the exception. Okay. So outermost orbit can have only maximum 8. This is what you are asking, Harshini. Octet rule. Outermost orbit can only have 8 beta. That's all.
Sir,
Okay.
is it only the outermost or every orbit?
No, only outermost. You see, like that, if you say, you see, xenon is there. It's 54. 2, comma 8, comma 18 are there in M. 18 are there in N. 8 in O. Okay, outermost only you should not be more than 8. Suppose if you are taking calcium, student, if you are taking let me take calcium. Where is calcium? Here, 20. So 2 comma 8 comma how much it should be, student? 2 comma 8 comma 10 it should be. But is 10 possible? No. 2 comma 8 comma 2 it will be. Why, sir? Outermost orbit cannot hold more than 8 electrons. Yes, Narendra.
So why can't it be 2, 10, 8?
2 comma
10, 8. I mean,
2n square, right? Formula is 2n square. Second orbit can hold maximum 8 electrons.
okay, sir.
Okay. Yeah, Harshini, clear your doubt?
Yes, sir.
Okay. So outermost orbit can only hold 8 electrons. It can't hold more than 8 electrons. Like calcium is 20. 20 means first orbit 2, second orbit 8, third orbit 2 into 3 square 18 it can hold. It can hold 18, but how many electrons are there? So 10 are already finished. So it can hold 10. That's wrong. As it is, if at all it is innermost, it can hold 10. But you see, this is outermost. So 2 comma 8 comma 8 comma 2. That's the reason calcium is 2 comma 8 comma 2.
Sir,
Yes.
so can you show again how do you use the 2n square formula?
Okay, 2n square formula. You see, this is first shell. K, its value is 1, its value is 2, its value is 3, its value is 4. Okay. Okay, in the K shell, 2n square formula. So n value kitna beta? 1. 2 into 1 square, 2. That's the reason K shell can hold only 2 electrons. You see any atom, any element you see. Okay. Then L shell, second shell, n value is 2. 2 into 2 square, 8. That's the reason it can hold only 8 electrons. If it is less, fine, but it can't hold more than 8. Okay.
Okay, sir.
Like m value is 3. So 2 into 3 square, it can hold 18. It can hold 18. Less it can hold, but more than 18 it can't hold.
Yes, sir.
Okay. Yeah. So I'll show you. Yes. Yeah. This is what you want to ask, Fadila. Stable electron configuration of inert gases or noble gases. Okay. Phi is not our. How does nitrogen hold phi in L shell? Nitrogen. So here 7, 2 comma 5. So how does so 5 electrons can be there, student? So who is stopping it? 2n square is the formula. 2 comma it can hold up to 8 electrons, but totally 7 electrons. 2 are already arranged, so it can only take 5. What is issue with odd and odd? Odd and even are not at all an issue here. Okay, odd and all not at all issue here. Okay, so in that way, yeah. So now, student, why did we start this topic? Why? Because we are going to explain ionic bond. That's the reason we have started this topic. Okay, so sodium 2 comma 8 comma 1. So when the sodium atom becomes ion, if at all, if I disturb their electron and protons configuration, okay, or denies, but it denies 2n square formula. No, student, it is accepting it. Okay, 2n square is a formula, student. Nitrogen is 7. Okay, so K shell, n value is 1. So how many electrons? 2 into 1 square, 2. Okay, K L shell, K L M N. L shell, n value is 2. 2 into 2 square is 8. But it only have 7 electrons. How can you adjust 8 electrons? So only the remaining 5 electrons you will adjust here. 2 comma 5. 2 comma 5. Okay. Yes. Okay. So students, so electropositive in nature. So you see student, as I said, outermost orbit always wants to be 8. So 2 comma 8 comma 1. So what is the best way to remove one electron? Now you should not say, sir, I'll take 7 electrons. It will become 2 comma 8 comma 8. It is happy. Yes, that's absolutely right. But only movement of up to 3 electrons is the easiest way, energy efficient way. Okay, movement of up to 3 electrons. So 2 comma 8 comma 1, 1 electrons to be loosened, minus 1 electron. Then you can say sodium ion. As it is having, initially it was having 11 atomic number. That means 11 positive charges, 11 negative charges. Now what did we do? We have removed one electron. That means positive charges we have not disturbed, but electrons we have removed one. So what is the charge? Plus 11 minus 10 plus 1. That is what we always write here. Okay, Na plus means Na plus 1. Na plus 1. Okay, so sodium will always form a positive ion. So frankly speaking, all the metals will generally form a positive ion. They always, their excess having electrons, they always want to lose electrons. Okay, they always want to lose electrons. Okay. Okay. Yeah, so now students, so that is what I said. So can we take already 7 electrons? No. Transfer of electrons up to 3 only energetically favorable conditions. Above 3, it's not easy. Like carbon is having 4 electrons in the outermost orbit. Will it give? Will it take? It will not do nothing. It will only share. Okay. Transfer of electrons up to 3 only energy favorable condition. Okay. Magnesium. Yes, Narendra?
So is it possible?
Is it?
Possible to give 7 electrons?
That's what not sir. It is not possible, I said. Okay,
Okay.
so in this case, you can give 7 electrons, you can remove 1 electron, but this is energy efficient condition. I said, okay, it's not possible to go and play with more than 3 electrons. Okay.
Yes.
Okay. Okay. Maximum electron it can have in a shell is 8. If at all it is outermost, if at all it is outermost, maximum electrons it can have it is only 8. If it is innermost, follow the 2n square formula. If it is innermost, follow the 2n square formula. If it is outermost, maximum is 8 electron. Okay, so students are still having some time. You see, I'm saying that if it is innermost, like you see, inner or inner particular shell, inner shell, here you just follow 2n square formula. 2, 8, 18. But as this is an outer shell, as it is a valence shell, you follow 2n square formula. But if at all you are getting more than 8, you should not take. Only 8 electrons only it will accommodate. Outermost orbit can only take 8. Understood, Strugal now? Okay. Like magnesium is 2 comma 8 comma 2, it want to lose 2 electrons, so magnesium 2 plus n, like that positive ions are formed, student. Okay, yeah, so the positive ions, so you should say electropositive elements. So metals are electropositive elements. Okay, so always they are wanted to have a positive charge on them, electropositive. Similarly, when you go for the non-metals like chlorine, you can see it's a non-metal. Okay, so yeah, here it is. So chlorine is here. It's on the right side. It's a non-metal, student. So if at all it is non-metal, what's happening here? Yeah, here. So it want to take 1 electron. You see 2 comma 8 comma 7. It has two options. It can remove 7 electrons. Then also it can be 2 comma 8, or it can take 1 electron and become 2 comma 8 comma 8. So which is a favorable condition? This is a favorable condition. That's the reason all the non-metals generally want to take electrons. Once the electrons are taken by this atom, negativity is taken, we write chlorine minus. Okay, because number of electrons are more now in here. Here it is neutral, here it is more. That is what negative ions. So negative ions are generally called electronegativity nature. Electronegative. Okay, so that is how the negative ions are formed. Now, why are we discussing this topic? We are discussing this topic to check the second student. What happened? All my slides got disturbed. Yes, we are discussing this topic to finally go for ionic bond. Okay, ionic bond. What is ionic bond? If you bring a metal and a non-metal, electrons will transfer from metals to non-metals. Why? They are having extra electron. They want to give electron. They are having less electron. They want to take electron. So that's the reason whenever they are just brought near under suitable condition, so transfer of electrons can happen. So that's the reason ionic bond is always formed between metal and non-metal. You see, many students lack the clarity over here. Ionic bond, metal and non-metal. Covalent bond, non-metal and non-metal. Okay. So once A and B are forming a bond, we call it as ionic molecule. Transfer of electrons has happened. Okay. So generally, we call it as a cation. Why? Why? Because always metals are having plus charge. Plus means cat has pos, cations. Okay. And always non-metals are having negative. So we call it as a no, anion. Anyone good conductors or covalent? Ionic bonds are good conductors, not the covalent bonds. Why? Because ionic bond can transfer the electron, not the covalent bonds. Okay. Yeah, yeah, this is okay. Yeah, so student, the questions will come like this for 2 marks or 3 marks. Explain the formation of sodium chloride. Okay. Even though you can express like this, but I will not ask you to draw all of this. orbital arrangement. It consumes some time. Okay, he will just ask sodium chloride. He will not say draw the orbital arrangement. Please go for the Lewis dot structure. It's very easy. Please go for the Lewis dot structure. Yes, good conductor in molten state or in the aqueous state. Purnappa. Molten state or aqueous state. Okay. Yeah. So you see sodium 2 comma 8 comma 1. Why sir? Because sodium atomic number is 11. Okay. Let me erase all of this. Sodium atomic number is 11. 11 is nothing but 2 comma 8 comma 1. So 1 is extra. This 1 will be moving here. Chlorine 2 comma 8 comma 7. It always wants one electron. That's the reason. Okay. So how will you write in your exam? You will write like this, student. Okay. Absolutely like this you will write. Nothing more than this. Nothing less than this for full marks. Okay, so how did the Lewis dot structure came? So Lewis dot structure, first of all, you should write Na is having only valence electrons will be represented Lewis dot structure. So 2 comma 8 comma 1. What is the valence electron? Only one. That's the reason 1 dot. Chlorine atomic number 17, 2 comma 8 comma 7. Valence electrons are 7. That's the reason 1, 2, 3, 4, 5, 6, 7. Okay, now you should show like this. It clearly shows the extra electron in the valence shell of sodium is moving to the chlorine to form a sodium chloride ion. Okay. Also, you need to write these two things. Valency, valency is if you are okay. So yes, Rujuta, can you say me what is valency definition, student?
So the outermost electron in the last shell
Oh.
is the valence electron.
Okay.
Sir, are you asking
Valency,
valence?
valency. I'm asking valency. Yes, very good, Harsh. Tanish, what is valency?
That's like the capability to form bonds.
Sir, it is the number of extra electrons.
Number of
Extra electrons.
extra electrons. You see, chlorine is 2 comma 8 comma 7. What is the valency here?
Sir, 7.
No, student, wrong. Yes, whom should I ask now? Yes, Jahnavi, are you there? Jahnavi, what is valency, beta?
So the outermost shell,
That is valence electrons, not valency.
how many electrons it needs to be
Very good. Combine. Yes, absolutely right. Harshini,
to
Narendra.
become 8, right?
To become 8 or to become stable also you can say. Okay.
Yeah.
Okay, so yeah, so it's a combining capacity of an atom. You see 2 comma 8 comma 7 Strugal. So for this atom, how many electrons it require? It require one electron to become stable. So what is valency? 1. Valence is always positive 1. But for sodium, it is 2 comma 8 comma 1. For it to be stable, what is the combining capacity? 1 electron it should lose. So what is its valency? Again 1. Okay, so valency and valence electrons are different. Valence electron means, sir, one valence electron. In this case, 7 valence electrons. One valence electron, 7 valence electrons here. But what is valency? Combining capacity. If it loses one electron, it is stable. So valency is 1. If it gains one electron, it is stable. So valency is 1. Understood, Sugal? Yes, yes. Okay. So stable means outermost configuration should be 8. That's all. That is stable. Okay. So yeah, so students, so this is what you need to write a molecule, and you need to write like sodium 2 comma 8 comma 1 electron to be lost. So you should say Na plus 1 electron. Okay, 1 electron is given outside. Okay. Chlorine 2 comma 8 comma 7 to become it stable, 1 electron is to be given. That's the reason product side you should show. So I am giving 1 electron to make it chloride ion. Sodium on the reactant side it is losing 1 electron. So please remember the way. Huh? So yes, magnesium chloride, I'm sure you can write it. You can write it like this. Okay, 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 okay. Okay, for yeah, you see, for this SSC Telangana students, you have suborbitals also, I guess, SPDF. Okay, there's some principal quantum number, azimuthal quantum number, all that story gets added. I have added some of the slides, but I was not able to explain you. Anyhow, I'll try to do. after the CBSE students examination. I think 10-15 days is more than enough for me to cover all of them. Okay, now we are moving to ionic bond properties. So ionic bond we have seen anion and cation. So what is ionic bond properties? The first property, you see crystalline means they are particular in one particular shape. Arrangement is a three-dimensional and number of atoms are same in all the direction. Amorphous, there is a zigzag, there is no particular shape. So you can first property you can say that ionic bonds are crystalline solids, crystalline in nature. The arrangement of their atoms is they are organized way. Yeah, their arrangement is organized. First property, ionic bonds are crystalline in nature. They are not something like amorphous. Okay. Second property, yeah. So this is what Sugar was asking. Water soluble. You just remember NaCl, Na plus Cl minus. Sir, something like ionic bond, metal, non-metal. Salt पानी में मिल जाता है बेटा. So daily you see in your real life. So that's the reason your ionic bonds are water soluble. Okay. Covalent bonds amorphous. Why are you saying student? Covalent bonds are non-polar. Okay, so they are non-polar solvent. So it's something like kerosene.
Sir,
So yes, covalent bonds you are saying amorphous. Yeah, most of them. Yes, Harshini.
sir, ionic bonds are insoluble in organic solvents,
Yes,
in all organic ones.
yes, you can say that.
Sir, covalent are soluble in organic.
Yes, covalent are soluble in organic. You see naphthalene, it's soluble in kerosene. Okay, we have done that particular activity, I guess. Okay, okay. What else? What else? Yeah, so they are water soluble. They are insoluble in inorganic or polar, non-polar covalent bond. Okay, so that's second step. Third step, as they are solids, they are, as you see, ionic bonds are somewhat what I say, they're structured, and ionic bonds are very strong bonds. So generally they are solids. Like NaCl, you can see solid. Obviously, to make it liquid, which we call melting point, is high. High. Again, as they are from liquid to gaseous state, also boiling point will be high. So ionic bonds, their high melting and boiling points. Covalent bonds are weaker bonds. We have seen in chapter number 4, low melting and boiling points. Okay, this is third property. Yeah, brittle also you can consider, student. I'll give one value, one sheet, all of them. Yes, conduction of electricity, very, very important point. Conduction of electricity. Ionic bonds will conduct electricity provided they should be in liquid or molten state. Okay, like NaCl is there. You see, there is an electrode, there is a battery. Now, if you just keep salt, that will not conduct. But if you add some water, that salt water will conduct electricity and your bulb will glow. Okay, so ionic bonds are good conductors of electricity in liquid or molten state. Liquid or molten state. Okay, yeah, so this is what the 3 marks question comes from. Okay, properties of ionic bond. Solid, if it is solid, you can't just make it ductile, it will be brittle enough. Okay, crystalline, arrangement is highly organized, high melting and boiling point, soluble in water, insoluble in organic compounds. Okay, conduct electricity in molten and aqueous state.
Sir,
Yes,
so brittle means soft, right? So like they're breakable.
yes, they are breakable. Yes,
But they're telling it's solid, like hard.
if you elongate, it will break. No, if you elongate it, it will break. That is the meaning. Brittle means. Okay. You see, something like what example did we take for polar? Yeah, you can see copper metal. Copper metal, it's ductile in nature. It is not breaking. It is just extending. Gold, you can extend up to 2 kilometers. Okay, that is ductility. But now this compound, they are highly struck. They are very closely packed. If you try to elongate here and here, the bond will break. It will not just elongate. That is what the meaning is. Okay. So what do you mean by what is your doubt, Ponappa? Again, say me.
So like they're solid, they're telling it's solid, but they're also telling it's brittle.
So solid means what should come? Ductile it should come.
No, solid it should not be brittle, right? So it should not break easily if it's
If
solid.
you use force, students, it's first of all they're very hard. If you use force for that particular solid, it will not elongate, but it will brittle. It will be breaking. That's the reason he said brittle. Okay.
Okay, sir.
Okay. It is solid definitely, but if you use extra force, it will break, but not it elongate. Okay. 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 One question. No, not this. Okay. So that's finished. Okay, students. So that is okay. So that is up to session number 6. Okay. So all are there. Somebody is missing. Okay, nobody is missing. Good. Okay. So let's go to session number 7. 1 second. I need to open my documents. I just close many of them because my system will be hanging. Okay, now we'll be going to the that particular point. Where are these metals found in Earth's crust? How to clean them? How to extract them? Those all questions. Those all topics I'm starting now. We finished about ionic bonds, electronic configuration, metals, non-metals, properties, chemical reactivity series. Now we are moving to the extraction of metals. Iron ores. Yes. 1 minute, student. Yeah, so Purnappa, right now, if you have a pencil in your hand, if you try to pull the pencil on both sides, it's a solid. So it will just expand or it will break.
It'll break.
So brittle, right? Solid is brittle. Okay, okay. Okay, students. So with that, we have completed this ionic bond and properties also. Now we are moving to occurrence of metals and its ores. Okay, where are these metals found? In which way they are found? How to make them pure metals? That is what. Okay, it is important chapter, sir. It is in yellow zone. Which one, student? So yeah, so this is you see, I have asked the students before going to this chapter. Should I start chemistry chapter number 1 or metals and metals and non-metals? It's a high scoring chapter. So most of the students said they want metals and non-metals in spite of chapter number 1. That's the reason I have started. Okay, so yeah, so now the question comes, where are these metals found? So we have seen many metals, right? So we have seen, you see, these all sodium, aluminum. Where are these metals found? Obviously, we have already discussed the metals are found in the crust. And what is the Earth's crust, student? From 0 to 80 kilometers. From 0, so top here from 0 to 80. These metals are found. How they are found? So they are found in free state also, combined state. What does that mean? Free state means, you see, gold is purely available as gold. Platinum directly you can take and make a ornament. Okay, little purification is required. That I'll come to that point. Silver. So they are in the free state. These all are found in the free state. But what about the other? Like sodium, it is found as a sodium chloride. Calcium, it is found as a calcium chloride, calcium oxide. So this is combined state. It is they are formed in a combined form. Okay, that's the reason, student. There is a necessity to understand how to extract calcium from calcium chloride, how to extract sodium from sodium chloride. That is what this topic is of. Okay, okay, students. So combined state, you can see sodium chloride. I want sodium. Aluminium oxide. I want aluminium. Manganese. I want manganese. Zinc carbonate. I want zinc. Zinc sulfide, I want zinc. Okay, so but they are found in the combined form. We want the particular metals. Okay, so gold is expensive because availability of gold in this world is 0.0001%. Okay, so first of all, it is less available, 0.001% or 0.01%. That's the reason it is costly. So extraction and if extraction cost is not there for gold, but finding gold is the toughest task. Okay, that's the reason it is costly. Can anybody say what is this iron 3 oxide means? Formula? Narendran, what is this formula? Iron 3 oxide.
Sir, Fe2O3.
Fe
2O3.
Fe2O3. Copper oxide?
Sir, CU1.
CuO. Okay, Rujita, copper sulfide?
Sir, Cu2S.
Cu2S.
No, CUS.
CuO. CuS. Okay. Yes, Fadila, mercury sulfide, beta?
HGS.
Okay. Okay, so student, so what does this mean then? So you see, copper sulfide, you said copper 1 sulfide, 2 sulfide. What does that mean?
Sir,
Copper
it's
sulfide.
a transition metal, right? So its valency can change.
Very good. That's the reason I'm mentioning bracket. Now you say, Harshini, sorry, no, Harshini, copper sulfide. What is the formula? Is it right?
Sir, Cu2S.
Okay, right answer. Okay, so student, here 1 means the state is +1. Okay, 1 means state is +1. But sulfide is -2. So how can I make this as neutral? I need to do S. 2 into +1 +2 -2. Cu2S. Okay. Copper 1 oxide. Oxygen you all know -2 is the charge. But copper 1 oxide means +1 charge is there. What should I make it to? Cu2O. Okay, then only +2 into 1, 2 and -2. Mercury sulfide. Sulfide is -2. Mercury is 2. That's the reason HGS is the right answer. Okay, mercury sulfide, mercury +2 means +2 charge on the top. Copper sulfide means +1 on the top. But you ensure that compound is neutral, right? Okay, Fe2O3. Oxygen I know -2. -2 into 3 is -6. Oxygen is having -6. So iron +3. 2 into 3 is +6. That's the reason it's a neutral. Okay, so that is nothing but the state, student. On above that, how much charge it should be. Fe3O4 is not, Fe3O4 is wrong answer. Fe2O3 is right. Fe3O4 is wrong answer. Okay, understood, Rujita, now?
Yes, sir, got it.
Got it. Okay. Okay. Okay, so now students, so now we should come to this topic, right? Okay, so student, yeah, this is what we get when you dig through the JCB long kilometers mining they do, right? You'll all get like this. Okay, what is this, student? This is nothing but natural material. So in this we have some metals like this. So if I'm taking this means I have some metals. That metals may be in the pre-state, that metals may be in the combined state. Okay, so this is a material in which if I have a metals like this, then we say it is a mineral. So natural material in which metals or their compounds are found is called mineral. Okay, when you dig the earth's crust, you will find this. This is a mineral. Why I am saying mineral? Inside this mineral, I have many things. Especially, I want metals inside, and metals are either in the simple state or it is in the combined state. Yeah, yes, Rugal.
I'm unable to see your screens.
Pardon?
I am unable to see your screen.
So I think you need to log in back again. Are you others? Are you able to see? Tanish, are you able to see?
Yes, sir.
Okay. Jahnavi, Aparna, Tanushri, you all switched off your videos. Okay. So that's a mineral, student. Now let us come to the next topic, ores. What are ores? Ores are nothing but minerals which metals can be extracted conveniently and profitably. Conveniently profitable, very important. Conveniently profitable. Suppose you are taking A and B. These two minerals I have taken, A and B. This you see to extract minerals. इसको minerals निकालने के लिए you are spending 150 rupees. In metal B, in material B, if you are removing these metals, for some part of the is having metals, if you are getting, if you are selling it for 100 rupees, in which way you got the profit? You got this as a profit. So you can say only this fellow as a ore, not this fellow. Both are minerals only. Both are minerals only. But to remove that minerals, it should be profitable and convenient. Okay. So this from this I got it. I costed 75 rupees. I sold it for 100 rupees. So 25 rupees is the profit. But here, if I sell it for same 100 rupees, I'm at the loss. So material A is not ore, it's purely mineral. Material B is a mineral also, ore also. Understood, Jahnavi? The meaning? Jahnavi. Please switch on your camera, student. Please switch on your camera. Jahnavi, Aparna, Harshini, Ayana. Please switch on your cameras. Try to be more realistic. Okay. So in that way, student, you should understand the difference between minerals and ores. All minerals can be, all ores can be minerals. No, all minerals can be ores, but all ores can't be the minerals. Okay. So I think we have that question also. No problem.
Did you call me?
Yeah, I called you. Were you not there?
Do you have a question? My internet was unstable, so it was getting stuck.
No problem. So concentrate here. Okay. So student, what you need to remember from here, you need to remember especially the ore's name. Okay. You see, sodium is extracted from NaCl, but in the Earth's crust, the mineral is nothing but the rock salt, and the business to remove the sodium from sodium chloride is rock salt. Bauxite is nothing but aluminium ore. Manganese is a pyrolusite. Zinc, calamine. Why? You see, zinc in the Earth's crust can be in two ways. Zinc carbonate also, zinc sulfide also. So if you are doing a removing zinc from zinc carbonate, that particular ore is known as calamine. Zinc sulfide ore is known as zinc blende. Okay. Similarly, iron, Fe2O3, hematite. Okay. Copper, again, copper is also having two ores, copper oxide, cuprite, copper sulfide, copper glans. Okay. Silver sulfide, so not silver, mercury sulfide is cinnabar. Okay, student? Cinnabar. This is what you need to remember the name, student. There is no option other than that. Okay. If you have some good trick, please help your friends by sending it in the group. Okay. Yeah, so now the gang. What is the gang, student? So you see, student, the mineral if you take, first of all, you'll have unwanted things, sand, rocky material, limestone, mica. These all are to be removed. Okay, that is the gang. So if you remove that, then you will get something like enriched mineral. Enriched mineral means what metal we want, that will be seen in more concentration. Okay, so all the unwanted impurities is known as gang. Yes, Sugar, that is what you're asking. I don't know, student. I don't know. Zinc, which is more profitable, I don't know. Okay, so student, to remove that particular metal, we have three cases, three steps, student. First step, concentrated and enrichment. Just now I said, right? The unwanted things are to be removed, waste materials are to be removed. Whatever that you can, by physically you can see, by little chemical process, that all you remove. That is your first step. We say enrichment. So initially all the muddy particles, sand particles, their concentration was more, but the mineral concentration was, metal concentration was less. But if you remove all of them, then the metal concentration will be more. Then that way you should say enrichment. For SSC Telangana student, you have some procedures, chemical procedure, physical procedure for the first step also. Okay, which we'll be learning after some sessions. Okay, but for CBSE student, you don't have anything about this. Only you need to say enrichment, impurities removed. Okay, the second step, you need to extract. What does that mean? As I said, this can be in the combined form, like zinc sulfide. Okay, zinc carbonate. But you want extraction, you need to extract the zinc from the zinc sulfide, zinc from zinc. That is the second step. Third step is a purification. You see, after this extraction also, some gold and silver particles will be left. So you need to purify them. Okay, so I'm purify them. Okay, student. Okay, the process of removal of gang, that unwanted things, if you remove, we call it as enrichment. That is the way we have finished first step, enrichment. Okay, second step is the extraction. Okay, so student, for the extraction, yeah, you see, student, here is a, all ores are minerals. True or false? Please give the answer. All ores are minerals. Harshini, Jahnavi, Narendran, Rujuta, Ponnappa, Tanish, Maya, Tanushri. Only two options, but many answers. Answer is A. All ores are minerals. Ores means what, beta? Profitable. If it is profitable, means it should definitely be from the mineral, right? But all minerals are ores? No. Like you see, I have taken two pieces, A and B. They both are minerals. But B is not giving me A is not giving me profit. It can't be ore. Okay, all minerals are ores, false. All minerals are ores, false. They both are minerals, but this is not giving me profit, so it can't be ore. But the reverse statement is true. All ores are minerals, true. Understood, Purnappa?
Yes, sir.
Yes, Amulya Ananya, good student. Okay, yes, Narendra, good. Okay. Okay. Yeah, so student, for understanding the extraction, I think I have divided this entire reactivity series, not reactivity series, basically speaking. Yeah, the reactivity source only. You see, I have divided the reactivity series in three parts. Look at here very carefully. Okay. Yeah, this is what you see. Reactivity series, we have three parts from the very first: high reactive, medium reactive, low reactive. But you see, especially for this topic, I have taken four categories. Four categories. What are those? Sir, the upper one are high reactive, the down one are very low reactive. Just above the down, just above the silver and gold, we have low reactive, and the middle one are moderate reactive. Okay, so the reactivity series I have divided into four classes. It is better to understand in this way this topic. Many things to remember here. Okay, so how to remember? You should classify first the reactivity series like this. Okay, yeah, you can see here silver, gold, platinum. What did we say? We said that they are found in the free state. So that's the student. They are not required to extract at all. Why? They are already found in the free state. What will you remove it from? Already you are getting a pure gold piece. There is no requirement of the second step for that. Okay, there is the second step. 1 second. Huh? 1 second. Yeah, you see, student, second step is not required for very low reactive elements. Second step is not required. First step, gang like impurities, that may be. Second step not required. Okay, that's the reason, student. We'll start from here. We'll start from low reactive metals. Okay, this step don't extraction is not required for this. So could you send today's recording? Am I recording it first? Let me check. Yeah, I'm recording it. Okay. So let us start with this low reactive. Okay, now you see, student, please send cats, monkeys, and zebras in lovely happy cages made of mercury, silver, gold, platinum. I have divided the entire reactivity series four groups. The last reactivity series not required as they are already found in the pure state. But now when you see this copper, how is it found? Copper sulfate, copper sulfide. What is that? I have shown that property, right? Yeah, you see here copper sulfide. So it is, so now I want to remove it as a copper. I want to remove that copper from copper sulfide. Next is mercury sulfide. I need to remove mercury from mercury sulfide. That is what the first extraction method is. Okay. Now let us start with the mercury sulfide first. Let me check where to start with. Oh. 1 second, student. Quite low. Leave it alone. 1 second. Where am? Yes, mercury. Okay. So mercury. So how is mercury found in the particular ore? It is found in mercury sulfide. Now I want to remove mercury from mercury sulfide. How can I do it? You see, student. Mercury metal is produced in sulfide as a cinnabar. The ore is cinnabar. This is what you found in Earth's crust, but you want this. Okay, how will you do it? Okay, first step, always for sulfide, you see I have taken here some screenshot, right? For low reactive series are generally found in sulfides. I'm not speaking about very low, I'm speaking about only low. Okay, low reactivity series, you see I'm speaking about this. They are generally found in sulfides. You see copper sulfide, mercury sulfide. And what you need to do, you need to do roasting first. What is roasting, student? Roasting is nothing but you need to heat it in presence of oxygen. Okay, so what is the first step to remove mercury from mercury sulfide? First step is roasting, heating the sulfide ore in presence of air. Mercury sulfide in presence of air, you need to heat it. So what will you get, student? First step, in the first step you will get mercury oxide and sulfur dioxide. You see SO, SO2, HgO, HgO. But is my task finished? My task was to remove Hg, but I got HgO now. Okay, that means I need to remove this oxygen. Removing oxygen means what? Reduction. What is reduction, student? Reduction have three definitions: removing oxygen, addition of hydrogen. Okay, reduction is removing oxygen, addition of hydrogen, and gain of electrons. We'll not go for all of them. Just now you remember that, sir, this oxygen is to be removed. Then only I'll get mercury. That is the reason we need to go for reduction. So mercury oxide, what is the best way of reduction? You just continue heating it. Okay. So for mercury sulfide, you continue heating it. Mercury oxide will become mercury. You see, we are roasting or heating it up to 300 degrees. That's the reason you get mercury metal very hot. Mercury metal will be very hot. This is a case-based question. It will be a mercury. So the mercury metal which you get from the extraction of mercury in which state? Liquid state. Why liquid state? Because we are giving extensive temperatures over here. Okay. In that way, you can say that you have found mercury from mercury sulfide. Okay, Rujita, are you following, student?
Yes, sir, I'm there.
Yeah, Tanish, go ahead, student. What's the doubt? Yes,
So
Tanish?
can we also use reactants such as carbon also to reduce mercury?
No. You see, that's the reason I said we want a profitable business. Okay. So for the experiment and the laboratory purpose, you can do anything. You can use, sir, for reduction. Let me use some reducing agent like carbon. But again, as this is this is a profitable business. This is what the standard step they're following. Okay.
So
Yes.
like sir, in exam we have to write it as we are reducing it by heat.
Yes, that's all. You need to just use it. We are just heating up to 300 degrees so that automatically this mercury oxide is getting to mercury metal. Yes, Narendra?
Oh.
Sir, anyway, carbon is more reactive than.
Yes, that is also one case. Yes, I'll come to that point. Because right now I have not shown where is the carbon lying in reactivity series. I have not given him the example. Yes, Strugal, I'll come to that point. Why we can't use carbon, I'll come to that point. We have that particular thing. Okay. So that's the mercury, student. Okay. Now the question comes, sir, what about the copper sulfide? You see, it is also low reactive metal. It also comes under that, and it is also sulfide. Can I use same roasting and oxidation? Absolutely, answer is yes. Okay. So copper sulfide, we call it as a copper glance, that ore. So here also you will get this thing, but you finally want to make a copper pipes like this. So from this ore, you want to remove copper. How will you do it? The very first step is same, roasting copper sulfide. In presence of oxygen, you will heat it. So copper oxide and sulfur dioxide will form. But is my task to get copper oxide? No, my task is to get copper. How will you get copper oxide from copper? Self reduction. Okay, very important word, self reduction here. Self reduction. Okay, self reduction. What is a self reduction means? You see, self reduction means, you see, first of all, what are we doing it? In presence of oxygen, we are roasting or heating. So copper sulfide, I took some in apparatus or some open environment, I am heating it. What will it form? You will form copper oxide. Okay, so on heating, you got copper here. Soon some of the copper oxide is formed. I have just to close this environment. Now what happened in this environment? I have two things in the environment. Some of the copper sulfide is still left. Some of them is converted to copper oxide. When these two combination comes, automatically it forms to a copper, student. When these two combinations are available, automatically sulfur plus oxygen, sulfur dioxide form, and copper will be left over here. Okay, this is known as self reduction. Okay, so I'm closing it soon after that. So that's the reason I'm using in the absence of air. Why? Because I have closed it. In the absence of air, copper oxide reacts with the remaining copper sulfide to form copper metal. Yes, Tanish, what's the doubt?
Sir, is it the same thing with the carbonate or also copper?
No. Carbon, totally different, totally different. Can copper oxide be a ore? Copper oxide be a ore? Copper oxide be a ore? I don't know, sir. May not be. But all that would be there. Yes. Okay, Jahan, I'll definitely give you the recording. Okay. So you see, if at all copper oxide is an ore, why will I go and find for copper sulfide? I would have taken copper oxide only and do this single step. Okay. So may not be. Or it may be something like it may not be profitable to take this much of copper oxide. Okay. Fadila, are you back, student? Are you there, Fadila?
Yes, sir.
Okay. Okay. This is the step number one. So okay, this is the so we have finished So what did we finish, student? We have finished two cases. What is that? So in the very reactive, low reactive metal, we have seen that both of them are sulfides, both of them are undergoing roasting and reduction. Okay, roasting and reduction. Okay, so that's the reason I just wrote like this. Okay, so what did we finish? So we have finished this much, the mercury sulfide roasting and heating up to 300. In this way, you need to remember in the memory map. Okay, what about copper sulfide? Sir, it is also sulfide roasting but self reduction. Only this much you remember. Okay, students? Yeah, next, let us go to the next part, student. What is the next part? So let us go to the moderate reactive metals now. So, okay, can you see what are the moderate reactive metals? You are able to see oxides, iron oxide, copper oxide, zinc carbonate, zinc sulfide. Okay. Now let me go for these two things first, then I'll go to the oxide. So still again in the moderate reactive metal, I'm able to see zinc sulfide, zinc carbonate. So here it is again sulfide. So Fadila, again I'm able to see sulfide, student, in moderate reactive metal. Can I use the same roasting? Can I use the same roasting over here? You see here sulfide, I have done the roasting. Can I use the roasting here also, Fadila?
No, sir, because it is zinc sulfide.
Uh-huh. Yes, Ponappa, you're right. So student, you can use, once for this sulfide, you are using roasting. This is also sulfide. So definitely student, so zinc sulfide, where is that? Where is that? Where is that? Yeah, zinc sulfide, you see, this is what you get from the ore, but you want to make it like this. So again, as it is a zinc sulfide, as it is a sulfide, first step is roasting. In presence of oxygen, you are heating it. Obviously, zinc oxide and sulfur dioxide will form. Okay, so first step is same. Yeah, next step, now you need to reduce it. Now the question comes, which is the economical way? Should I heat it? Should I self-reduce it, or do I use some of the other particular reducing agent? The answer is reducing agent work. Why, sir? Why the reducing agent works here? Because this is the reason. Okay, this is the reason. Yes, carbon, right answer. For sulfide, roasting can be done. Carbon can be used as very good. This is the right answer. Okay, Harshini, right answer, student. Okay, so the first step is still same as it is a sulfide. First step is still same, roasting. Yeah, definitely from zinc oxide, I want zinc. So now you can see, student, you see where did I map carbon? Student, carbon is first of all non-metal. So practically speaking, I should not add carbon here, but only to make you know where does the carbon lie in the reactive. It is just above zinc. Okay, so only to make you aware. So don't quote this reactivity series. Carbon is a non-metal. This is a reactivity series of metal. So from this you can say, sir, here carbon is more reactive than zinc. That means if I use carbon, definitely zinc and carbon is more reactive. Carbon will replace zinc. Now, how can a non-metal can replace a metal? Yeah, so you see, student, oxygen is here, carbon is here. So we are having carbon monoxide compound. Okay, so you'll find those things in your higher classes. Right now, you understand that zinc and carbon both are there. Carbon will replace zinc, and zinc will be alone. Carbon monoxide will be formed. Why? Because in this particular reactivity series, you can see carbon over here. Okay, you will find the answers more in your higher classes, definitely. Why don't they do it for the copper, sir? Where is copper? Here, right? So copper we have not discussed, huh? We have discussed, right? Copper sulfide. Okay, but where is copper? Copper is here. Carbon is here. Okay. So you see, student, this is an economical. He is saying, right? Student, why carbon is required? Copper is self-reducing it. Why carbon? Why do you want to waste the money? Why do you want to use the carbon? So you see, some of the students is saying, sir, why are we not using carbon for the reduction of copper sulfide? Okay, I'm coming to that side. You see, copper sulfide, we already got copper oxide. Why will I use carbon when already they are automatically self-reducing it? Okay, so we need to make it economical. We want profits. Okay, that's the reason, student. Carbon, even though laboratory you can use it, I guess, but in the large amount they are already self-reducing it. Understood, Sugal? Okay. Yeah. Okay. Now, student, in that way we have finished zinc sulfide. Okay. Now let us go to the zinc carbonate. So here also some zinc carbonate is, but I want zinc. Okay. Yes, Harshini, what is the thing, student? How will you use it? How will you find it? Yes, right.
Sir, calcination.
Okay, very good. What is the meaning of calcination, Harshini?
Sir, heating but in absence of air.
Very good. Okay. Exactly. So, student, so you see, I have finished three things and I have given one line statement roasting and reduction with carbon for zinc blend. But now I am starting with zinc carbonate. How does that, you see, moderate? We have two things either sulfide means roasting, either carbonate means calcination. That means this is what the calamine ore is. I want to make it as zinc metal like this. What will I do? I'll do the extraction. How will I do, student? The first step, calcination. What is calcination? It is also the heating only, strong heating, but in the absence of air. Zinc carbonate, in the absence of air, it will become zinc oxide and carbon dioxide will become CO2. Okay? So you can, can anybody give another reaction, another name for this reaction other than calcination?
Sir,
So
decomposition.
decomposition.
Okay. Yes, very good. Decomposition. Any other name? Thermal decomposition. Thermal decomposition. You are giving excessive
Redox reaction.
redox reaction. Thermal decomposition is right. Yes, Ponapa, absolutely right. Thermal decomposition, Rujita, right. Redox reaction. I need to check the oxidation state, student. I'll just check that oxidation state. Like you can see, carbon is having how much? Zn plus 2 minus 6 plus 4 plus 4. Carbon is not changing. Zinc plus 2 plus 2 not changing. No, student, it's not a redox reaction. Okay. Yeah, so again, but do I want zinc oxide? No, I want zinc. Okay, so again, we have a very easy way. Let me use the carbon for the reduction of that zinc. So zinc metal and carbon monoxide, you'll get it. Okay. So and the carbon what we are using is in the coke form. Coke form here, the cheapest form.
The coke form means
Coke form is
solid.
a
The coke form means like
uh,
solid liquid.
you see
Yeah.
solid.
Okay.
Okay, so in that way we have finished four things, student. We have finished. Where is the fourth thing? Okay, we have finished this one, this one, this one, this one. Okay, student, we have one more thing. Where is that manganese pyrolusite? Yeah, manganese pyrolusite. Can anybody say what is the method we use for manganese? MnO2. I want Mn.
The reduction with aluminum.
Reduction with aluminum. Very good. No. Okay. Right answer. Okay. So student, manganese again. I just want to show where does that manganese lie and where does that carbon lie. You see, student, zinc is here. Carbon is just above the zinc we have seen. Manganese is here. So manganese, the ore is manganese oxide. Can I use carbon? No. The carbon is least reactive. Carbon can never replace manganese. That's the reason, student. I need to select above elements, above metal. That's the reason manganese oxide is reduced with the help of aluminium. So manganese ore, this is what the pyrolusite. You want ultimately this extraction. How will you do it? There's a single step. Manganese oxide, you need to react with aluminium, which is more reactive than manganese. So that is how aluminium will replace here. Manganese will be alone and aluminium oxide will be alone. Okay. Again, here it's a highly exothermic reaction. That's the reason in this procedure, whatever manganese is got, highly exothermic, very high temperature, we get it as a liquid. We get it as a liquid. Okay? Okay. So in that way, we have finished manganese also. Okay? Yes. So now, so student, iron oxide, whatever the leftover things are there, iron oxide, copper oxide, iron oxide. So you see, iron is here, carbon is here. You can definitely use carbon over here. Okay, that's the reason. Or you can use aluminum also here. You see, aluminum also here. But I think with carbon is a cheaper one. Carbon is cheap. So if you want to reduce iron, so you can use carbon. So even though I have shown you iron oxide plus aluminum, definitely aluminum will replace iron because highly reactive and it is a highly exothermic. We have seen the thermic reaction also in the chapter number 1. It is also liquid. But why don't carbon? Carbon is also right, student. You can use carbon also. Yeah, you see aluminum we have done, copper oxide we have done, manganese oxide we have done. Okay, so you can use carbon also with them. Carbon also you can use for reduction. Okay, students. So in that way we have finished the low reactive materials also, I guess. Okay. Yeah, so the moderate reactive materials also we have finished. Okay. Now what are we left with? We are left with high reactive metals. Okay. Any doubt still here, student? Any doubt will here? Yeah, I'm also responding most of the doubts in the chat. Okay, like Shrugal, Ponnappa, some of the students are chatting continuously. So, student, 90% doubts I have cleared, but some of the doubts are out of my context. Okay, you see, this is a big business, so I can't quote why they are not using Cu2O as an ore. Okay, I can't give the answers to this. Okay, my knowledge is limited to your CBSE and just above the limits, but not the business part, right? Yeah. So the ninth question, so the second last session. Okay. So student, what did we learn? We have learned that every mineral will need to go through these 3 steps. This is a very easy step. Just remove the gang. This is the extraction. In the extraction, we have seen these fellows don't want the extraction. They are already in the pure form only. Definitely these metals require the extraction. This and this we have completed. Now let us go to the high reactive metals. They are already high reactive metals. You can't use some carbon to reduce them because this magnesium is more reactive than carbon. How can it reduce? Okay, so now let us see what method we use for high reactive metals. Okay, yeah. So students, in your textbook it is given this, but I still find there are some lacking in this. I think my this way is better than that particular part. You see, least means sulfide. Sulfide means roasting. After roasting, you get oxides. Oxides can be reduced, and finally purification is required. Moderate, we have 2 things. Like you say, moderate, we have 2 things. Sulfides also, carbonates also, some oxides also. So you see, sulfide means again roasting, you'll get oxide. Carbonate means calcination, you get oxide. If oxide, reduction is required. And final stage is purification, which I did not discuss. Okay. Now we are moving to highly reactive elements, something like this. So they all will undergo electrolysis in molten state. Okay. Electrolysis in molten state. 1 second, sir. I want to take screenshot. Okay, take it. Okay, so a lot of hard work has been done to make all of them streamlined. Many websites, many reference books. Okay, then my friend and we both sat. He finally wrote this. Okay, okay. With that, let us go to the high reactive metals. So, student, high reactive metals, as the name only, electrolytic induction. So, some electrolyte should be there. Electrolyte, that means some liquid should be there. As electro is there, some battery connection should be there. If the battery connections are there in this particular chemistry, there should be cathode and anode. Okay. So, before the topic discussion, I need to mention what are these cations, anions, cathode, and anode. Yes, Maya. What is positive, student? Cation or anion? Positive. Cat has phos. Cation. Negative, obviously, ulta. Yes, Tanish. Cathode. What should be its charge?
It's a negative.
Negative. Very good. Student, is it right? Yes, it is right. Why? Because cathode should attract cation. Cations are positive. What should be cathode? Negative. Okay. Similarly, anode should attract anions. Anion is negative. It should be positive. Okay. In this way, you remember, student. They're very important. So don't get confused at all. So yes, Danish, right? Okay. Thank you, Aparna. You're still there. I'm happy to see that. Okay. So let us start with electrolyte, highly reactive metals. So let me state NaCl. Let us start with NaCl straight. Okay. You see, this is the rock salt, what we generally find in the market. We are directly consuming nowadays. Okay. Now from here we need to go for the sodium metal. You see, sodium metal, we have seen the physical properties. It is easy to cut, soft material, easy to cut. Okay. So anyhow, we need to make from here to here. What are the procedure we are doing? We are just following electrolytic reduction. Okay. So what is the first step for that? First of all, we need to have some molten form of that sodium chloride. So NaCl molten form. That means you need to melt it or you need to just mix it with water. Okay. So right now in this particular business, they're molten. They're heating it to a large temperature. So molten sodium chloride has formed. You see, student, NaCl molten means it converted to liquid. It is Na plus Cl minus. Why? For it is nothing but ionic bond. When it changes, it has some charges on it. Okay. Sodium metal required. So sodium metal is required first of all in as a large purpose. I don't guess where is it. Let me check. Let me check sodium metal. Okay, so here the students, so NaCl, Na plus Cl minus. Okay, so two things. So liquid state they have formed into Na plus Cl minus. Now, as I said, who is electrolysis here? NaCl is molten state is electrolyte. Now, as I said, electrolyte reduction, battery and it. Now you see, student, this is cathode. Why? Negative charge is connected to this is cathode. This whole rod become cathode. Why? It should attract Na plus. Cations it should attract. That's the reason it is cathode and it should be connected to negative charge. Cl minus anions, it should be attracted by this electrode. What should be this electrode charge? Positive. Positive, how can it maintain its positive charge? It should be connected to the positive terminal. Okay. So in that way, extraction of, so in that way, the connections are left. Okay, student. So let me just show you one particular video where I think I have shown you in the sessions also. Okay, now what is happening? Just observe it, student. Okay, where is that? Chemistry, metals and non-metals, final, electrolysis of NaCl. Okay, so in molten state, we have taken NaCl, student.
State or in a solution which conducts out.
Yeah, you can see now NaCl is Na plus Cl minus. Obviously, now I'll put some platinum electrodes and finally connect to a battery like this. Now you see this is positive. So positive means it should attract Cl minus. Anode it is. Okay. It is negative. Negative terminal connected. It should attract Na plus. Okay. Like this, Na plus is getting attracted. So now once you can switch on the circuit, positive charges Na plus will go near cathode and get attached to the cathode ions. Now, what is happening here, student? You see, you see here what is happening from the battery. Electrons are coming. Electrons are going to this cathode. But what is Na plus? Na plus means it is having one electron less. Na plus. It's not Na. It's not Na atom. It's ion. One electron is less. So that's the reason, student. Whatever electrons are coming, it is consumed by this Na plus, and Na plus plus one electron is just becoming Na plus is this, and here one electron is there from the battery. So they both are mixing and finally become Na atom. And we want Na, right? So like that, all the Na. Similarly here, Cl minus, chlorine minus means one electron is extra. One electron is extra. So here you can see positive terminal. So this particular terminal is having less electrons, or you can say some deprived of electrons. So electron Cl minus is having one extra electron. It is going and attaching to this anode. So now what will happen, student? Obviously, like Na has become Na atom, Cl minus ion will go and give one extra electron from its atom to here. That is what Cl plus plus Cl minus. Now you see Cl minus, what is happening? It is becoming chlorine ion. What about one electron? That went inside that particular anode. In that way, you are getting chlorine gas. Chlorine can't be alone. Chlorine is diatomic molecule. So chlorine gas. Okay. So you need to write these two things, students. Okay. You need to write these two things in your exam. Yes.
So can you explain me how Na became 1 again?
Yeah. You see Na plus. What does that mean, student? 2, 8. Na atom means atomic number 11 beta. 2, 8, 1. But you see here it is Na plus, means one electron is not there. Okay, one electron not there. But when this particular Na went there, you see Na plus went there, which is having 2, 8. Electrons are here in this particular cathode. So one electron from this cathode is giving to Na plus ion. Yeah, you see, one electron is transferred from here to here. Na plus from here plus here. Now you see, obviously, Na plus 2 comma 8, Na plus means 2 comma 8 is there. One electron came from here. It is 2 comma 8 comma 1. What is 2 comma 8 comma 1 is of? Nothing but Na atom. There are two things are there. Na ion, Na atom. Na atom means 2 comma 8 comma 1. Na plus ion means 2 comma 8.
Okay, sir. Because
Understood?
plus is there, that's why one is gone.
One is one. Okay, now he is taking 2 Na plus, so he has taken multiply 2 on all the sides. Okay. Fadila, are you following, student? Any doubt, Fadila?
No, sir.
No. Okay. Sujita, any doubt, beta?
No, sir, got it.
Okay. Okay, at anode. Yes, Strugal, yeah, go ahead, student. What's the doubt?
Sir, won't Na they catch fire?
So where am I mixing with? This is a closed apparatus, first of all. And Na, he is not taking with water. That's the reason he has taken molten. You see, molten means he is heating it. Na can become, you see, if I take NaCl plus water, then also Na plus will be forming it. Okay, Na plus plus Cl minus will be forming. Pure Na will catch fire, beta. But you see, you are consuming salt daily. In your particular blood, we have water also. But is it catching fire? So all the properties changes once Na is getting bonded with Cl. It's not that you should compare the Na properties with NaCl. That's a total change.
Okay.
Okay. Okay, so students, the same ideology you can use for other elements also. Like you see, in the right NaCl I have explained, Al2O3 also. This is also high reactive. Definitely, that should also be heated. You see this NaCl is a liquid, but that heating of NaCl is Al2O3 is not so easy. You need to add some molten cryolite, Na3AlF6, some molten cryolite. If you add them, then the boiling point of Al2O3, which is 2072, is reduced to 11,000 degrees Celsius. If you add this molten cryolite with the Al2O3, its boiling point is reduced. Then you heat it, then it will become liquid, and the remaining story is same. Okay. So students, in exam, you need to write this. Without this, you will not get any points. Okay. What action is good? First of all, you need to write this. Al2O3. Al is formed, O2 is formed. But how it is formed? At cathode, what is happening? At anode, what is happening? You need to write this.
Sir, can you show the slide where Cl is becoming one?
Because it is, yes, that's a, yeah, student. Cl is becoming one. Huh?
This slide.
Yeah, this one. Okay, chloride minus ion, you see, chlorine is 17 beta. 2 comma 8 comma 7. Okay, so chlorine is 2 comma 8 comma 7. Minus 1 means 1 electron is already there here. It is 2 comma 8 comma 8. So it need to lose 1 electron to become 2 comma 8 comma 7. Okay, chloride ion,
Yes, sir.
losing 1 electron to become chloride atom. Okay, but chlorine can't exist in single, double. That's the reason Cl2, if I'm taking, you need to balance it by multiplying 2 on the left side. As you have taken Cl2, you should take 2 over here because NaCl is what you have.
Okay.
Yeah. So what's some student has sent me some doubt. It's platinum used because it's inert. Two reasons I may guess the platinum. You see, first of all, boiling point of platinum is more. Okay, you see here we are already heating NaCl. So if at all I use something like other rods, that may melt. That's the reason they are using platinum, I guess. Okay. So here here we are using iron cathode we are using. Okay, so that depends on the boiling point, student. I want electrodes which have more boiling point than this liquid. Okay, in that way we have finished the extraction also. Okay, you want to do one question? Yeah, do this question, student. Assertion and reasoning. Let me see who are still able to understand the things. Narendran. Tanish. Oh, student. Aparna. Fadila. Narendran and Fadila seems to be right. Strugal is right. Ponnappa, no. Rujuta, no. Tanish, right now. Harshini, absolutely right. Appu, no. Ananya Mulya, right. Student, you all got confused. Metal oxide, what is this? Metal oxides are basic in nature. How can A be true? Okay. Amphoteric means they should react with both acid and base. Definitely. So A is false, R is true. Yes, Aparna. Danish, what is this three? Maya, right. Sujita, understood beta?
Yes, sir. So aluminum oxide and zinc oxide are basic in
Metal oxides, right? Metal
metal.
oxides. Okay. You can say they are amphoteric. Their oxides are amphoteric. They can react with acids and bases. Okay. But metal oxide, basically basics in nature. Hmm, let's not go to many of them. Okay. So we are going to the last session of this topic. Good to see that I am on time so that I can complete one sample paper at least. Oh, what is it? What did I click? 1 second, sure. Click something else. Ah, yes. Harshini, got tired?
No, sir.
No. Okay, so let us go to the last step. What is this? Purification is still left. How do you purify it? Okay. Yeah. So student, first of all, who does not require purification? First, this top group does not require purification. Why? Because you have already used electrolysis procedure, which is already you whatever you are getting Na, Al, already the purified form. There are no impurities at all. Okay, that's the reason, student. Purification is required for these three. Again, I'm repeating, purification is required for this also. Okay, silver, gold, and platinum also purification is required. Okay, but why? Because in silver, some of the gold particles might be there. Okay, in gold, some of the platinum particles must be there. Okay, I'll just confirm this. I think the last time I just got some confusion on this. So right now you understand that top this high reactive metals does not require purification. Definitely these two will be checking it. Okay, yeah. So here purification. So we are in the last step of purification. We are in the last step. Okay, obviously this is already pure matter. You see, this is already we got pure metal. We don't want a purification here, but definitely this fellow, we are at the last step. Okay. Yes. Let us see the purification procedure. Okay. So student, as you have already seen, electrolytic extraction. So what is the procedure? Electrolyze. So what is the procedure, student? Okay, electrolysis we have already seen for extraction. The same procedure will be using for the purification also. Procedure is same, but little changes are there. Okay, but we see here the word is electrolytic refining, electrolytic purification. Okay, there is electrolytic extraction or electrolytic reduction, but here it is electrolytic refining. Okay, so yes, you see many metals like copper, zinc, tin, lead, chromium, nickel, silver, gold. Yes, gold and silver also require here. Okay, the confusion is lost. So this particular last group also require electrolytic refining. Okay, these all are required for the purification, student. Okay, and how are they refined or purified? Electrolytically. Okay, again the story will be same. Some liquid will be there, some anode cathode will be there, some anion cations will be there. Okay, so let me go for direct example. Okay, so what we'll be doing, student? Let us do copper let us go for the purification of copper. Okay, you see, let me go for the steps. So how did we get copper? We got a copper as copper sulfide. What we did to do, student? We have roasted it. As it is sulfide, we have roasted it, and we got copper oxide, right? CuO we got, I guess. Okay. From copper oxide, again with the self reduction, we got copper. But now this copper is not pure. So we need to refine it. That is what we are doing right now. Okay. So what we'll do? Okay. You see, student, whatever you want to refine, you will take it as an anode. Very important MCQ parts, huh? He will be asking you which will you consider as anode. The impure copper, whatever you want to refine, whatever you want to purify, you will take it as anode. And from the company and from the industry or from the market, you will take pure copper. Small part of pure copper, you will take it here. And the liquid is again copper sulfate. So there are three coppers here. Impure copper, which you want to refine, pure copper, which is thin, you have bought it from the market, and acidified copper sulfate solution. The liquid itself is a copper sulfate here. Okay, three things are there. Okay, now you'll connect with a battery like this. Will you connect with a battery like this? Okay, now students, let us see what has happened here. Okay. Yes, refining of copper. Okay. You see, student, first of all, acidified copper sulfate. That means some HCl or H2SO, little 1 ml or 2 ml I have added to copper sulfate. Okay. Copper sulfate. Why acidified copper sulfate? What does it do? It will break into Cu2 plus and CSO4 2 minus. You see, I want ions. So, student, one thing I'll say you in chemistry for electricity, that medium should be in liquid, or you can say ions will conduct the charges. But in physics, like copper wire, aluminum wire, there should be free charges. So in chemistry, there should be ions, free ions. In physics, there should be charges. Remember that way. So now this is chemistry, but I am using electricity. I want some liquid. That liquid is nothing but acidified copper sulfate solution here. So what does it do? What does it do? Now you are having in this liquid, you are having some ions which can conduct electricity. You see, Cu2 plus, 2 charges, SO4 2 minus. Okay, that is what sulfate ions, copper ions we have. Okay, students. Yes. Now let me. So once the battery is connected, you know what is anode. It is connected to which terminal. Cathode is connected to which terminal. You already know it. Now you see, once I connected the battery, cathode is negative. It will attract copper ions. So what will happen here, student? Cathode is having full of electrons. Why, sir? Why is that cathode is having full of electrons? You see, where is the cathode connected? Cathode is connected to the negative terminal. That's the reason this cathode is full of electrons. Cu plus is having electron deficient. Plus means it doesn't have electrons. So electrons will jump from cathode to Cu plus. Now once electron is jumping, what happens to Cu2 plus? It will become Cu. It will become Cu. Well, that is what we want. So this particular part is bulging now. Why? It was pure copper, thin copper, extra copper came, it started bulging now. So pure copper is going to be getting deposited to the originally pure copper. Now what happened here? So obviously sulfate ions will, yeah. So here you need to understand one thing. Whatever liquid, whatever we have, it need to maintain its concentration. Maintain its concentration means whatever Cu2 plus has been taken by this cathode, that should be replenished by this anode. Why, sir? How can it replenish? You see, anode is also copper. That's the reason, student. Two copper ions will jump from anode to this liquid. You see, once it got bulged here. You see, yeah, again jump. So what happens? Some of the copper will again jump here to form an ions. Okay. So two electrons has been taken by here. Two electrons have taken by copper ions have jumped. Now again the story continues. So this cathode is negatively charged. It will again attract Cu2 plus and again it will become bulge. Okay, so come on, go. Yeah, you see it has bulge. Like that the story continues and this cathode will be bulging. This anode will be reducing its thinness. Okay, so you see some of the copper ions are displaced, it becomes thin. Okay, this is the story that happens there. And finally, you can see that this whole impure copper will become very thin like this. All the copper has been deposited, so it is very thin. It became fat now. Now, where are the impurities? So, students, in this some gold and silver impurities will be there. That is not being attracted by the cathode or anode. That's the reason that impurities will be depositing at the down. We call it as an anode mud. Anode mud. So, what is anode mud? Gold and silver impurities. What is anode mud? Gold and silver impurities. That's the reason, student. All the impurities will be deposited below anode. We call it as anode mud. Okay. So here what is important? What is important is, what is electrolyte? Copper sulfate. What is thick block before the experiment? That is anode, which is nothing but impure copper. What is thin strip before the experiment? Thin strip is nothing but pure metal, which is nothing but cathode. Okay, these questions are very important here. And again, the for cathode and anode, the reactions are still same. In this way, we have finished ultimately purification. Okay, the final part and the easy part, corrosion is still left. You see, copper will be corroded like this, student. We need to avoid it. So why the corrosion happens? Corrosion, the meaning of the corrosion is the deterioration of metals. Okay, so whenever you see air, moisture, and chemical reaction is happening, you get the things corroded. Like you can also say aqua regia gold is corroded or dissolved. Okay, like you see copper with the water, carbon dioxide in the atmosphere, oxygen in the atmosphere. When these combination comes, it forms copper carbonate, copper hydroxide. You see on the tap some green and blue color. That is what these two components are. Corrosion of copper. Okay, corrosion of copper. Similarly, silver also will get corroded. Okay, any doubt? Yeah, AI anode impure. Okay, very good. Anode impure. Acha. Okay, silver also you see at your home, silver jewelry will get corroded. Okay, how silver with the oxygen in the atmosphere, you will form silver oxide, which is black color, and some of the H2S, which we call it a septic gas or some gas. So with these two combination, it will become dark gray to black, silver sulfide. Okay, so this is again corrosion. Silver also get corroded. Okay, so iron, yeah. So now you see, Strugal, you are asking something. Iron object in the presence of air and moisture, it gets covered to a reddish brown flake and forms a rust. Okay, air and moisture, student. If you keep in water also, it is supplied with air and moisture there also. Okay, it will be corroded. Okay. Yeah, so now how will you avoid corrosion? Obviously, so student, I think we'll discuss this rusting more in your chapter number 1. So how will you avoid corrosion? We have some of the best practices, like painting is one way you can paint, applying grease so that the outer surface is somewhat inert to the environment. Okay, galvanization, which is one of the important, where zinc zinc will be painted like in the molten zinc. This iron rod is just dipped so that all the zinc will be deposited on the topmost layer. So in that way, you can, okay, tin plating. You see, you found tin plating in particularly silencers, silencers. Okay, in a program. Alloying, especially the steel. Iron, we don't use it because it gets rusted more. So we make it of steel. What is steel? Very important. Chromium, nickel, carbon. We need to mix with iron. Okay, alloying, we say mixing different metals and non-metals also. Alloy doesn't mean metal plus metals. It may be metals and non-metals. Yes, the iron nail experiment. Yes, the same. Okay. So in this way, we can just say we have finished this particular chapter. Okay. Okay. So who doesn't corrode? Which doesn't. So silver also corrodes, students. Gold is what that doesn't corrode. Followed by platinum. Okay. Followed by platinum. Yes.
So can you show me that brass
Ah,
composition?
yeah. Take this. Take this. Okay.
It
So
come in my exam. I didn't know it.
okay. Okay. So thank God I'm covering most of them. So yeah, I'm able to see many students are saying, sir, this was in my exam, previous exam, I got this question. I'm covering most of them, student. Okay. So some of them which I have not covered, you see, I'll start sample paper that will be covered. Yes, Narendran, you're saying something.
So nothing saying that golden other bar which you showed in the other slide.
Gold and this one, student.
Yes, sir. I just wanted to say that was platinum.
Very good, very good. That's platinum. I thought silver. Good. Platinum. Yes. Metals which doesn't corrode, absolutely right. Platinum and gold. Okay, students. So with this, we have completed. Students, now you have understood. So have some confidence in you. I'm sure that we have done a long session. Okay, some things might be missed, something must be, as our memories are volatile, some things may be vanished. But now let us check by looking the CBSE paper. Okay, with the knowledge at least, so memory power is okay. If you go through this chapter one more time, at least your NCRT you will remember. But concept you need to understand. And definitely, I'm repeating it for the second time. Definitely, it will be stored in your memory somewhere else. Okay, you will find it somewhat easy when you read it for the third time. Okay. Yes, Strugal, you're saying something. The doubt, why is food not coated with zinc but with tin?
Yes, that one.
Food.
Yes, like it's not like coated. Like why is tin used for
Okay. So
preserving?
yeah,
Yeah.
so that concept we have already explained in chapter number 1. I'll come to that part again. Okay. So
Okay.
we have seen in the first chapter. So in that particular packets, why nitrogen gas is filled, why tin glasses were used. We have discussed that thing. Okay.
So, sir, like why not with zinc? That's my doubt.
Okay. So students, so that should be economical also. I need to check it. So which way is right? Okay. Okay, students. Now let us see the sample paper. Okay, sample paper. Okay. So bear with me for another 20-25 minutes. Now all your presence will be not be useful if you just leave now. Okay. Bear with me for another 25 minutes. You see, this is what is planned. This is what you can expect from this chapter. Okay. Whatever we have read about the physical properties, exceptions, they are for the MCQs. Chemical properties, today this is where we have started. They are from 3 to 4 marks. Reactivity series, again MCQ. Ionic compounds, electronic configuration, properties, 3 marks. Okay, metallurgy, just now we have discussed how the roasting, reduction, refining happens. That comes for generally 1 to 2 marks. Corrosion and prevention, the last topic, that for 1 mark. Okay, in that way you can expect 10 marks from this chapter, student. Okay. So now you decide whether you want to concentrate on, if you don't have time. For the students who are aiming for good marks, I request you should go for all. For the students who don't have time, who are just thinking, so no sir, we want to just have some decent marks. You see, this is where you need to concentrate. 3 to 4 marks. So spending less time, getting more marks should be your logic. Okay. Yes, student. So how does painting help us? Yeah, how does painting help run rusting? So student, rusting is nothing but if the atmosphere, oxygen and moisture is on the metal, rusting starts. Now, if you paint it, you're separating it. That moisture and oxygen, that metal is not getting just reacted, right? Yeah, definitely. Again, paint will also react. That's the reason you should go for the regular painting. Yes, Harshini.
Sir, in galvanizing, after we galvanize, even if the zinc layer is gone, the iron particle will not rust. Why?
Iron particle will not rust.
Yeah, it's still protected even if the zinc layer is gone.
No, student, I don't think so. Iron goes for rusting. It is with the aluminum and magnesium. There is the concept known as passivation.
Sir, in the textbook, they just gave it like that. Even if the zinc layer is gone, the article is still protected. Why?
Then why to paint with zinc then? Why to galvanize it? I don't think so. I'll just check it if at all it is given in NCRT. Okay, so aluminum and magnesium, they are having passivation concept. Things get rusting, right? Student, painting can only be a precaution for some days and months. It's not the permanent solution. Okay, you need to repaint continuously. You see, the gates, the house gates, or the ventilator grills, we regularly paint it. Okay, that's not the permanent solution. Okay,
Sir, what is essay 1, essay 2?
I think this is what you have it in the previous concepts. Okay, short answer 1, short answer 2 type. Right now you don't have it. Okay, but the mark strategy is still same. Huh? They're taking a friend. Okay, so let us see students. Okay, so let me open this particular. I'll not open this thing. I'll open this sample paper. Okay, so where is the sample paper? Chemistry, science sample papers to edit, science 2006 sample paper, science sample paper. Okay. Okay, so section A will be biology, section B will be chemistry, right? Yes, student. Okay, I'll just say whether this question lies on this or not. Which of the following equations represent redox reaction and what are the values of P and Q? Redox reaction, that is actually chapter number 1. Students, as this is MCQ, whether you want to give the answer, yeah, try to give the answer, students. Let me see who all just remember the chapter number 1. It's also from chapter number 2 also, you see. Chapter number 1 is a reaction, chemical reaction. Chapter number 3 is metals and non-metals. They both are actually overlapping. We can't perfectly differentiate between which chapters. Okay. Yes, Fadila right, Rujita right. Rujita, why it is redox reaction, student? Others give the answer, student. Why it is redox reaction? So Rujita is saying both are redox. Huh? Others, you can give your own answer.
Because firstly, because ferric oxide is getting reduced to ferrous.
Okay, very good. So what is
Aluminium
that?
oxygen.
Oh,
So
okay, right answer.
yeah,
So
first one is reducing and the second one is oxidizing.
first one is very good, student. Very good. Okay. So you student, oxygen is lost. So reduction is going on. Reduction is going on. Okay. Here you see aluminum to aluminum oxide. Oxidation is added. Oxidation is happening here. Okay. That's the reason. First reaction is a redox reaction. Both are I am able to see. Okay. Okay. Shrugal, let me see. No. Shrugal. Ponnappa, no. Maya, right answer. Tanish, no. Okay, so Tanish, so first definitely equation number one is redox reaction. Okay, equation number two. Yes, Vijita, equation number two. Why it is redox?
Sir,
Yes,
in the
right
second
answer.
one, C4H10, like it loses hydrogen.
Okay, so we
And
okay losing hydrogen. So losing hydrogen is oxidation, right?
yeah, oxidation. And
Oh,
carbon gains, oxygen gains hydrogen, so it's reduction.
oxidation. Acha, reduction. Okay.
Yeah.
Yes, student. So, student, even though what she said is right, but that's not the way to check whether oxidation and reduction is going on or not. Okay. The best way to check the oxidation and reduction is to go for the oxidation states, which I'll explain it in the chapter number 1. Okay. Even so, that particular question, what's the logic she said, even that will also give the right answer, but that's sure for only 99% case. 1% case, there are some reaction where you need to take the help of oxidation state. Tanish, D is the right answer. Butane is
Sir, I
oxidation.
gave B.
D is the right answer. Both are redox reaction. And p value is 2. You see, iron is 2, student, so 2 should be here, and q is 10. Hydrogen is 10, hydrogen is 20 here, q should be 10. 10 twos are 20, so D is the right answer. Yes, Harshini, I have given your answer. I have seen your answer. The answer is right. 18th question, student. Yeah, so this is a perfect question from this chapter. Is Tanushri there in my session? Ananya, Amulya respond. Ayana, please respond. Fadila is responding. Harshini responding. Maya responding. Narendran responding. Ponnappa responding. Shrugal responding. Tanish responding. Aparna is also responding and try to respond it again. Yes, so student Rujita, so I'll explain for everybody. Yeah? So that you save that particular question for the chapter number 1. Yes, I think Tanish, you are right. Rujita is right. Harshini right. Fadila right. Ananya Amulya right. Aparna right. Very good, student. Right answer. Okay. So calcium oxide with dilute HCl and aqueous sodium. So what is the question? One second. Oxide. So okay. Yeah. So Tanish, why is first one wrong? Google right answer.
No,
Maya.
sir, first one is actually right.
First one is right. Okay.
Sir, but then it can react with both, right? The first one.
Is it so? Anybody? Why the first one is wrong? Harshini, Narendran, Rujita, Fadila, Maya.
Sir, it is
Sir,
right.
it can react, it's amphoteric.
So why did you give the acha, so okay. So first one is right, you are saying. Acha, so options are one
Yes,
and
sir.
I'm sorry, I'm just seeing ABCD option. Right answer. Second one, yeah, calcium oxide. Yes, Aparna. Why this is right or wrong? Aparna.
Sir, it does not react with
Why?
aqueous
Why
sodium.
reason? Reason. You remember something like that?
Yeah, but I forgot the name of that.
Okay. Yes, Shrugal. Why second one is wrong?
Sir, because it's not an amphoteric oxide. It's just
Very good, very good. Okay, so student, calcium oxide, metal oxide can react with acid. Base can react with acid, but base can't react with another base. There are only few exceptions like aluminium, zinc, lead, I think stannum. These are the only metal and metal oxides which may react with acids and bases. Calcium oxide is a simple oxide. It's a base. Base can't react with another base. Okay, so that's the reason 1 and 3 are the right answers. B is the right answer. Good.
Sir, one more reason is that sodium is more reactive than calcium, right?
Yeah, go ahead, student. What is another reason?
Sir, sodium is more
Very
reactive.
good, very good, very good. Calcium oxide plus NaOH. No, student. No, no, no. You should not use that logic at all. Why, Fadila? Why that logic is wrong?
Sir, because sodium is more reactive than calcium.
No, I said the explanation what you gave is wrong. What Sujita gave explanation, what Fadila is wrong. Yes, Narendran.
The double displacement.
Very good. This is a double displacement reaction. You should not use that reactivity series logic at all. Double displacement reaction, no logic of that reactivity series. Good. 19th question. Very good, Maya. Right answer. Harshini, super. Reactivity series only helps for the displacement reaction, not for double displacement. The displacement reaction is a transfer of
Our Indian
atoms.
is coated with blue coating.
Very good, Aparna. Displacement reaction is a transfer of atoms. Double displacement reaction is transfer of ions. Okay. Ionic bond and covalent bond is transfer of electrons. There are many differences. So Ponnappa gives some answer. Tanish, Ponnappa, same answer. Fadila, same answer. Strugal, different answer. Rujita, same answer. I think Strugal, all the four of them give the same answer, student. You should check yourself. So whenever such questions are here, try to iron nail, Fe, or reacted to P and Q. P and Q. Okay, P is having copper sulfate. This is P. Q is having silver nitrate, AgNO3. Silver nitrate, AgNO3 twice or silver nitrate, NO3. I think AgNO3 only. So now he's asking Q. This is Q. This is P. Yes, I think. Yes, right answer, I guess, student. Shugal, right answer. Now your Narendran, okay. Amulya Ananya, right answer. I think B is the right answer. You see, iron is more reactive than silver. So iron will replace this. So first of all, there will be color changes. Okay. No reaction, no reaction, wrong. Okay, this will also, iron is more reactive than copper. So definitely iron will replace, no reaction is wrong. I think only B is satisfying. The remaining thing have no reaction, but only this coated silver coating. Yeah, so B is the right answer. Yes, Narendran, what's the doubt, student?
I got a bit
Confused. Okay, so whenever these questions are given, please make it an equation. Then you can use that reactivity series concept. Okay, good to see many students give the right answer. Methyl orange, acids, bases, and salts. pH, acids, bases, and salts. First chapter, I guess. Aqueous solution, double displacement reaction. Carbonates compounds. Aluminium wire stand. Aluminium silver. Yeah. Question number 25. I'll ask, please read the question. I'll ask the students. Otherwise, you can give it in the chat box. Will the students observe change? Yes or no? At least you give. Narendran, very good. Harshini, very good. Oh, very good, Harshini. Right answer. Fadila, very good. Tanish, very, very good. Acha, Harshini change your answer. Acha, second option. Okay, very good. Yes, Tanish. What is the answer, student? Strugal, okay, good. Ponapa, good. So you see, he said there is a setup in the science lab. He clamped. So this is an aluminum wire, student, and a small pin is fixed over here. Small pin over here. Free end using the wax. There is a wax. Okay, wax means that can melt easily. Then he heated with the burner. He started heating this aluminum wire. Okay, obviously the heat will be transformed from here to here. Obviously the wax will melt and the pin will fall. Now the question comes here. If the teacher replaces aluminum wire with a silver wire, will the students observe change? Yeah, yes, Tanish, say me.
Sir, no, sir, no, the pin will follow after a long time.
After a long time, okay. Harshini, you the answer?
Sir, yes, they'll observe as silver is a better conductor than aluminium.
Student, silver is a better first. We already seen the physical. You see physical properties of metals and non-metals. From there, he framed this question. We have seen silver is the best conductor, heating best conductor. Silver followed by copper, followed by gold, I guess. Okay, then comes aluminium. So as silver is a very good conductor, the heat will be transferred at very fast. So you can see that pin will fall at the very less time. Silver has high thermal conductivity than aluminum. Right answer, right justification. Pin will take less time to draw. Very good. Understood, Tanish?
Yes, sir.
Okay.
I
So
went
pin,
with the reactivity series, so I did this mistake.
reactivity series is for the displacement reaction. But here he is just asking aluminium and silver. So you should just see the properties, physical properties here. Okay. Yeah, the next question. Will the aluminum wire melt? Yes, Shrugal. Will the aluminum wire melt? Give reason for your answer.
Yes, sir, it will not. It won't melt
Won't melt. Why?
because aluminium has like high like melting
Okay,
point.
okay, okay. So you can give that. Okay. Melting point of aluminum is more. We have seen aluminum melting point. We have added cryolite. Okay. So I think its melting point is very high, so it will not melt. Right answer. Good. 26th question. A. Ananya Amulya. Are you there, student? Ananya Amulya. I don't know whether you are watching it or not. Please give the answer, Ananya Amulya. I want the answer from you both now. Harshini, Rujuta. So what is the question? I have not read the question. Hello, okay. Okay, okay. Right answer.
So 26th, either A or B or both A or B.
No,
A and
you start with A, beta. We'll go for B. Don't worry. You start with A. Okay, Harshini and Ruchita is right. Ponnappa, very good. Fadila, very good. So Fadila, the answer is can we store X in water? So don't predict that particular metal name. Yes, very good, Ruchita. Right answer. Tanish, very good. Catch fire. No, yes, right answer. Narendran. No. Okay, very good. Ananya Mulya, very good, very good. Now I'm so Maya, good. Okay, yes, right answer. Very good, student. Okay, so student, obviously you can't store it in you can't store it in water because element X is stored in cannot be extracted from reducing agent and ionic compound cannot be reduced to reducing agent. It is higher reactive element, higher reactive metal. Higher reactive metal means it will react with water, and that is the reason it is stored in kerosene. Okay, so those all story you write it. Identify element X, name the process. Yeah, okay. Now you all are right. So why student all are giving sodium only? Can't it be potassium? Who said so? You see, potassium is also the higher reactive metal. Why we have discussed only sodium? That's the reason you are all giving sodium. Can anybody? Why can't be potassium? Acha, Narendran gave at least two options.
So NaCl is an ionic compound, so we took it as sodium.
Why KCl is not an ionic compound?
In NCERT, they gave NaCl.
Is this NCERT question?
No, sir, but in NCERT, they had given example of NaCl only mainly while forming the bond, ionic bond.
Then you have colorless.
Yes.
Sir, will they give marks if we write NaCl?
Acha, is it
so
like
it's an alkali metal.
did he mention that? Element X is stored in kerosene and cannot be extracted from its ore using a reducing agent. Okay, so anybody better answer? Yes, Harshini,
Sir,
Fadila.
but it's most likely to be sodium. Like,
Why?
Sir, does KCl exist in the first place?
Yes, now you are right. Okay. Extracted from its ore. What is the ore of KCl? NaCl, I know it is, what is that? Rock salt. But KCl, I don't know. I think this word is what it is a catchy point. He spoke about ore. So in your syllabus, we have an ore of only NaCl. That's the reason Na might be the right answer. Okay, good.
Sir, but potassium ore is like potassium, right?
Huh?
With ore.
Yeah, so I did not explore it, student. I need to check it up. But we have not discussed, okay? And he said it is from the higher reactivity series and it's ore, okay? And if at all it is potassium, potash, I need to check it. Oh, what is this? Europe and these domes and other greenish and what domes are very greenish, copper, and orange, red in color. What
Sir,
is this?
I have a doubt.
Go ahead.
Earlier you explained like how is
Your voice
electrolytic.
is cracking. Your voice is cracking, student.
Sir, how is electrolytic reduction different from electrolytic science?
Electrolytic reduction, you are doing it for the compound. You see, you are doing it for Al2O3. You are doing it for NaCl, electrolytic extraction. But electrolytic refining, you are using it for single element, single metal, Al and Na, which is impure. Okay, first difference is this. Procedure is same, but whatever you are taking electrolyte is different. Okay, here in
Okay.
electrolytic extraction, you are extracting aluminum from aluminum oxide. But electrolytic refining, you are cleaning impure aluminum to pure aluminum. That is the main difference.
Okay.
So is this from this question? Okay, let me see the question I have not. The domes of many buildings in Europe are made up of copper. These domes now appear greenish in color. Okay. Why do the domes appear greenish through copper is orange red? Yeah, so the first answer is corrosion. Okay, and the reason is copper carbonate and copper hydroxide. In your opinion, should the copper domes be replaced by iron domes to overcome the problem of change of color of copper domes? No. Iron is more prone to the particular corrosion. Okay, so are the students? No, iron will corrode quickly. Very good, Tari. Harshini, very good. Okay, Ponnappa, very good. Shrugal, corrosion of copper, fine. No corrosion iron faster. Very good, very good. Domes used to made from thin sheets of metal. Why did the ancient architects use copper to make domes? Domes used to be made from thin sheets of metal. Why did the ancient architects use copper to make domes? Can
Sir,
anybody?
because copper is valuable and was easily available.
Domes in thin sheets of metals. Why did ancient architects use copper to make domes? Cheaper and comparatively less reactive. Maybe.
Malleability also.
Malleability also. Malleability also is one right cause. Okay. Because they want, yes, absolutely. Malleability is what the point. Okay. You see, sheets of metal, sheets. The metal that can be made into the sheet, plate is malleability. Okay. Copper is more malleable is the right answer. Yeah, more right answer is sugar. Malleability concept, student.
sir, it is also like a thin material compared to
Compared to?
other thick iron and all.
Okay. So actually we need to see it should not corrode also. It should be malleable also. Those are all we need to see. Okay. Yeah, Tanish? What's the
Sir, it
doubt?
is also because copper is comparatively less reactive, so it takes a longer time to corrode.
That you already give the answer, right? In the second question, in your opinion, copper comes iron domes. No, copper will not replace by iron because iron will corrode
No, sir,
fast.
I'm talking about the third question.
Domes used to made a thin sheet. Why did ancient? So yes, your answer is right, but that point we have covered in second for topic only, student. Here we said iron we should not replace because iron will corrode more faster than copper. So I think malleable point is you can add 2 points, but malleable point should come here. Malleability. Except malleability and easy
Sir,
availability, it's also durable. Yeah. Go ahead.
shouldn't we like add more than malleability because all metals are malleable, then why only
Most
copper?
malleable and less corroded.
Yes, so we need to add two
Yes, you
points.
need to add it. Yeah.
So in the question only they had given.
As he is speaking about corrosion, you should add corrosion. Okay. Like the one which Sanish also saying, right? Yeah, Punap, what's it out?
So in the question only they had given to use the keyword because they told thin sheets.
Exactly. Okay, who is this? Amita, electrolyte, is this from this topic? Cathode and anode, I think this is from this topic. Huh? Okay, so the last question, I guess, student. I don't know whether there is another question or not. Amrita electrolyzed distilled water using a setup shown in figure 1. She was expecting two gases to be allowed at anode and cathode. Okay,
Sir,
so
I
this
think
is
this
the
is
first
chapter 1.
chapter 1. Okay, so do you want to leave it? Leave it then. Ah, yeah, this is again this chapter. Yeah, please give the answers, students. Identify the type of reaction. Please type the answers A, B, C. Only for hardly 5 minutes, sir. Please bear me. Please bear me. Only 5 minutes.
Sir, isn't this chapter 1?
Yeah, we have done today also, right? Zinc oxide with we have reduced it with the carbon. Why chapter 1?
Yes, sir, but they're asking type of reaction.
Okay, you
So,
at least you give the reaction pertaining to this chapter at least. Yes, Tanish, right answer. Yes, right answer. Okay. Okay, I'll give the answers for all these questions, sir. Don't worry about the answers. I'll send the sample paper. So right now I'll send the yesterday's sample papers, which I did not send. Okay, very good to see many answers. Good. So student, if at all it is from this chapter, we'll go for the reduction of zinc oxide. But as he's asking type of reaction, the first chapter is the top priority. Okay, the first chapter, I think this will become for redox reaction. Okay. Again, if this chapter, it's zinc carbonate, calcination is right answer. Okay. But as the question is from the first chapter, it should go for decomposition. Okay. Oh, many answers came. I'm not able to see all the answers. Decomposition, right answer. So thermal decomposition is a better word, because you see he has given the word heat. So please use the thermal decomposition. That would be better. Still fine. Decomposition will also give you a mark. Reduction, decomposition, not reduction only, student. Redox reaction. Aparna. Reduction means oxidation will generally happen. Reduction,
Yes, sir. I understood.
understood, right? Yeah, this is combination.
combinations.
That's all. That's all. Anybody? Anything
Sir,
else?
exothermic also.
Exactly. Okay. Exothermic. You see, on the product side, heat is given. So exothermic also can be added.
Sir, all combination reactions are exothermic, right?
Like that. H2 plus O2. H2O.
So I got confused. Decomposition reaction or endothermic, I guess.
Okay.
Sir,
I
like
think
Hold.
in NCRT, when they were talking about exothermic, they gave combination reactions as example.
Acha, acha. So one of the example he might have considered. Okay? Not a 2 ml of NaOH, pink in color, acids and bases, leave it. Justify your answers, leave it. H2SO4 NaOH, draw balance reaction, leave it. CH, okay, chapter number 4, leave it. This one we have discussed, leave it. Hydrocarbon, chapter number 4, leave it. Yeah, metals and non-metals. So this is where which question show how many marks? No, how many marks? 4 marks? 3 marks? 3 marks, I guess. 5 marks. Oh my god, 5 mark questions. So student, last question, last question. We'll do it and stop. So please give only the first answer. Which type of bond is formed between carbon and oxygen? Only give the first answer. I'll check point wise answers. I can't check all the answers at a time, student. If I say you're right, then go ahead. Very good, Rujita. Go ahead. Rujita, check your answer, beta. Tanish, right answer. Fadila, right answer. Maya, right answer. Harshini, right answer. Narendran, right answer. Very good. Come on, Ananya, Amulya. Come on, beta. Easy question. I'm sure you will get it. Aparna, very good, Appu. Ponnappa, Vadappa, Maya, no.
Sir, should I do
Tanvi.
the next one?
Okay, next one you are giving students.
Next one, sir.
So please type B and give the answer, right? Please type B and give the answer. Fadila, right answer. Maya, right answer.
Sir, even mine, the next answer
Yes,
I'm
right
getting.
answer, right answer. Okay, so Rujita, you see carbon, non-metal, oxygen, non-metal, beta. Non-metal and non-metal. Covalent bond.
Sir, I overread it as calcium and oxygen since I saw.
Okay. Okay. Ye covalent bond, right answer. Amulya Ananya, wonderful student, wonderful. Okay. So next, calcium and oxygen. Calcium is a metal, oxygen is a non-metal. Metal and non-metal, ionic bond. Okay, very good. Very good, Fadila. Which of the above compounds will be good conductor of electricity in molten state? You see, is it COO or CO2? Student, CO2 both are non-metals. They can't be. Yeah, metals are good conductor. Metal oxide in a liquid form, molten state. Okay, so CaO is the right answer. C. Fourth one, comment on the physical state CaO and CO2. Let me see who will give this answer. E. Okay, valency of carbon verb. Right answer. Very good, Ananya Mulya. Rujita, right answer. Harshini, very good, Harshini. No, Narendra, no. Valency is asking. Valency's ability to form a compound by making it stable. It may be losing, it may be gaining, it may be sharing. Solid at room temperature because it's ionic compound. Very good. CO2 is gas at room because low melting. Oh my God, right answer, Fadil. Absolutely. So, student, so Fadila, what I suggest is, you see, this question is for 5 marks better. You see, students, so one more thing what I want to give is, this question is for 5 marks. What Fadila gave CaO at room temperature as it is ionic component, it should be solid. CO2, it is something like a covalent bond, intermolecular weak forces, it is gases. Okay, this is absolutely right. But please don't write that much. He will find any some mistake is there. He will, as it is only 1 mark. Please give the pinpoint answers. I'm sure that I'm very happy you all know more than what he's asking. But please don't write. Save your time. Save your marks also. Okay. Please be pinpoint to the questions that is asked for 1 mark. Yeah. If it all this question is asking for 2 marks, what Fadila said is absolutely right. Yeah. Valency of CO2. Okay, Rujita, please give the answer less. Very good, up to there, Rujita. Very good, Tanish, right answer. Valency 4, right answer. Harshini 4, Maya 4, Ponnappa 4, beta Ponnappa. Shrugal, oh, Shrugal, covalent ionic. Very good, absolutely up to the point. Narendran 4. Okay, so students, don't get confused. Sir, CO2 is a covalent bond. How are you speaking about valency? Valency is nothing but either sharing, it should be stable, or losing of electrons it should be stable, or sharing of electrons it should be stable. So here carbon is sharing electrons plus 4. 4 is the valency. Valency will always be positive. You should not say, sir, carbon will have plus 4 and minus 4 state. Can we say valency is minus 4? The answer is no. The valency itself is positive number. Okay. Thank you, students. I think I have taken 8 minutes more, but I'm happy that I have calculated the right timing of 3 hours. Thank you for attending this particular marathon session. I'm happy that I'm helping you all with some more marks than whatever you're struggling. Thank you. Any doubts? Please point me in my WhatsApp. Okay. Some of the doubts are asked by, I think, Shrugal, and some of the doubts which are asked by students, I was not able to know because I want to double confirm it before making a statement. Okay. Yep. You can point out the questions in my WhatsApp group, student. Not in the group, to personally at least. Thank you, students.
Thank you, sir.
Thank you.
Fine, thank you, sir.
Thank you. Thank you, Rujita. Thanks a lot.
Thank you, sir. Bye, sir.
Thank you.
Thank you,
Bye-bye.
sir.
Thank you. Bye-bye.
Sir,
Yes.
I had doubt in the sample paper. Still, should I give it personally or I can do it now? It was the first question.
Today's sample, in what
Today's
did we discuss?
Yes, sir.
Okay, so hold on.
The first question